Good afternoon, Honorable Vice Chancellor, Professor K.V. Chandrasekhar Garu, respected Registrar and Professor of Computer Science, Professor Y.K. Sundar Krishna Garu, Principal, University College of Arts and Science, Professor D. Surichandra Rao Garu. Today's webinar resource persons, Dr. Saroj Kumar Biswas, NIT Silchar, Dr. A. Srinivasul Garu, Blue Crest University, Liberia, Head of the Department, Computer Science, and Convener, Dr. Vijay Kumar Garu, colleagues, and all the participants. Good afternoon to one and all. I welcome all the participants to the webinar on data science applications using machine learning and deep learning techniques. First of all, I thank our beloved Vice Chancellor for granting permission to organize this webinar. Here today we have two eminent speakers, Dr. Saroj Kumar Biswas, who is expert in data science. He is from NIT National Institute of Technology, Silchar. And another one is international speaker, Dr. A. Srinivasalu, Blue Crest University, Liberia. Regarding this webinar, there is a lot of demand for skilled data scientists is on the rise now. And in the next decade also, there is a lot of demand for the data scientists. Machine learning is now being used to make sense of every kind of data, both big and small data. Data metrics are driving every business decision. The job market scenario for data scientists will grow to almost 11.5 millions by 2026. Companies are busy ramping up their data science workforce to enable high efficiency and planning. For the students who hail from non-technical backgrounds, good prior knowledge of analytical tools such as SQL or Excel, these can help them kickstart a data science course and career. If you lack programming skills but still have a good understanding of concepts such as logical programming, functions, and loops, dive in with your career journey in data science. Hope that this webinar will help you in your future career. With these few words, I hand over the mic to Dr. Krishna Mohan. Thank you.
Thank you, sir. Now I request our today's guest of honor, Professor D. Surichandra Rao Garu, Principal, University College of Arts and Science, Krishna University, to deliver the guest of honor message.
Hello? Hello?
Yeah, you are audible.
Hello, Krishna Mohan. Krishna Mohan. Sundar Krishna Garu.
Sir, add here, sir, already.
Your name is speech?
Yes, sir. Surichandra Rao, sir, first.
Invitation,
sir.
Screen record.
Krishna University, Professor K.V. Chandrasekhar Garu, Registrar, Krishna University, Professor Y.K. Sundar Krishna garu, resource persons, Dr. Saroj Kumar Biswal, NIT Silchar, Dr. A. Srinivasul garu, Blue Crest University, Liberia, Head of the Department of Computer Science and Webinar Convener, Dr. R. Vijay Kumar garu, Webinar Director, Dr. R. Kiran Kumar garu, the faculty members and learned delegates. Good afternoon to all of you. I'm indeed happy to associate myself with the one-day national webinar on data science applications using ML and DL techniques. Cited the way various departments of University College of Arts and Science compete among themselves and organizing webinars during this pandemic for the benefit of the stakeholders. For the first time since inception of this university, I am observing a quite healthy competition among various departments in organizing various academic events. This is the fourth national level event in the last 10 days. Every department took this activity as a prestigious event and setting new benchmarks by selecting the topics of contemporary relevance, collaborating with premier institutions, and by inviting renowned experts, both from India as well as from other nations, and from the academics as well as from the industry as well. By the direction of our beloved Vice Chancellor, the University College of Arts and Science set everything ready to release a webinar calendar for the academic year 2021, 2021 and 22. This calendar comprises of various national and international level, online and offline, the seminars, conferences, workshops to be hosted by various departments, details of collaboration, names of resource persons, probable dates of the respective events. With regard to the topic of the national webinar, undoubtedly, it is a topic very much relevant to the present day context. Since computer science is a dynamic the subject, the faculty and the students of the computer science shall always be on their toes to catch up the latest trends. By seeing the profile of the resource persons, one from NIT Silchar and another from an international university, Blue Crest University, Liberia, I'm pretty sure that and quite confident that all the delegates will receive rich insights on the topic of the webinar and update themselves on the current developments on data science. With these, the few remarks, I thank the organizers for the opportunity given to me. Thank you, one and all. Over to Krishna Mohan.
Thank you, sir. Thank you for your and with the cooperation of Vice Chancellor. Thank you, sir. We are sure that we will conduct more webinars in future with the kind cooperation of Vice Chancellor and Registrar. Now, I welcome today's another guest of honor, Professor Y.K. Sundar Krishna Garu, Registrar, Krishna University, to deliver the guest of honor message. Sir.
Respected Vice Chancellor, Professor K.B. Chandrasekhar Garu, and Principal, KRU College of Arts and Science, Professor D. Surchandra Rao Garu, and Head of the Department, R. Vijay Kumari Garu, and Director of this webinar, Kiran Kumar Garu, and our experts, eminent experts from NIT Silchar, Dr. Saroj Kumar Garu, and another expert, A. Srinivas Rao Garu from Blue Crest University, Liberia, and my dear staff members and participants. Good afternoon to you all. I feel very happy. I'm very thankful to our Honorable Vice Chancellor for providing such excellent opportunities for the university faculty members and other participants from outside the university, not only at state level, so at national level, organizing this type of seminars, where the university things will go up to not only national level, tomorrow it will reach to international level also. So particularly, so the Department of Computer Science, so organizing this topic, so that is content the reliance topics. In particular, today's webinar on data science applications using machine learning and deep learning techniques. And nowadays, the demand of this particular topic is very high. So, because as a computer science professor, I can say the last 30 years of experience, we started using simple computation with DBase and COBA. Then we started to different languages like Fortran and other things, scientific side. And slowly, so the computation goes to the network-based computations, distributed computations, and slowly now web-based technologies also come. The days has come today, so everything we want to make an automation. So this automation also in clear. So people used to write a program for automation of a particular equipment or particular machinery or particular system. Even these days also we are going one more ahead. Instead of writing ourselves program, we are writing a program such a way that our program will learn how to run the machine. So our program will learn how to run the machine. This is what is called machine learning. So therefore, so this approach is maximally probabilistic, because we are writing a program. So using this program, the machine, by taking several examples, training examples, it will try to learn a new algorithm, new hypothesis. So using that best hypothesis, we will use our machine learning application and we will run a machine automation. So therefore, it is a statistical approach. Therefore, there are several developments in statistical approach, and day by day different languages, different tools are coming. So one has to go through in details about these one side machine learning and deep learning techniques, other side is the tools. So I can suggest one thing. So there are several ideas are there. So one is using Python or you can also use MATLAB. So depends upon our R studio, depends upon the complexity of the project. Either we can use simple R studio or even Python in-depth advanced Python techniques, or if somebody can go for MATLAB is I feel a very good environment where you can do wonders. So even the defense type of applications with simple coding, so one can do wonders in MATLAB also. So nowadays the best tool is available for us is Python. So I suggest you can go for IPython, NumPy, and also Pandas. These are all the areas one has to familiarize. And also Matplotlib. This library is also very useful. And then machine learning techniques. This is a one sequence where you can go to IPython and then NumPy and then Matplotlib, Pandas, Matplotlib, and then go to machine learning, then deep learning. So this way you can practice and you can also do wonders. At the same time, day by day different techniques are coming. You should be competent enough and you have to choose the best ones. Okay, these are all the challenges for the computer science things. Other thing is, it is not limited to the only computer science domain. It is only computer science is a general domain applicable to for all other domains. So if you want to go for any machine learning, you should be a domain expert also in particular area, either civil or mechanical or electrical or any other area. You should be expert in those areas also. So having both domain knowledge and as well as this computer science and statistical knowledge, definitely one can reach to very higher end. So I request all the participants kindly go through the workshop, the seminar clearly and note down all the points, and you try to develop your own projects and go for higher level career. Thank you, sir. I thank you, the Department of Computer Science, for providing this contemporary relevance topic for the audience. And I also very much thankful to our Honorable Vice Chancellor Garu for providing and supporting such a good facilities to all of us. Thank you, sir. Thank you very much.
Thank you, sir. You made us realize the importance of data science and its applications. And you also introduced us about various software tools that are going to be used in the data science area. Now I request today's chief guest, Professor K.B. Chandrasekhar Garu, Vice Chancellor, Krishna University, to deliver the chief guest message. Sir, please unmute yourself, sir.
Okay. The Registrar Krishna University, the Professor Y.K. Sundar Krishna Garu, Professor D. Surachandra Rao, the Principal, the University College of Arts and Science, the Program Organizer, Dr. Kiran Kumar, the Head of the Department, Dr. Vijay Kumari. So today's the eminent personalities, the resource persons, Dr. Saroj Kumar Biswas, NIT Silchar, Dr. A. Srinivasulu from International, that is a Blue Crest University, Liberia, the participants, friends. So good afternoon to everybody. So the Department of the Computer Science, the Krishna University, the starting the national, the program on the data science application, the using machine learning and deep learning techniques. So a very good topic that chosen by the Department of the Computer Science, Krishna University. So in Krishna University, they started 2008 with the six PG programs. So one of the important the PG program is the MCA, Master of Computer Applications. So after that, the Krishna University established the engineering college, self-finance engineering college, offering the computer science and engineering the course as a BTech program. So overall, the 12 faculty members are the working in Krishna University with an MTech background as well as a doctorates. So among the 12 faculty members, the 50% of faculties are doctorates. So they established the good number of the laboratories in Krishna University for MCA as well as the engineering students. The recently, the 4 laboratories are established in Krishna University with nearly the 140 the computers and other facilities also provided for students. So the Department of Computer Science and Computer Science Engineering also developing the other laboratories. But one thing, why don't you collaborate with the NITs or other international the universities or institutes for the learning the computer subjects or techniques to give a good academics for the computer science the students, not only computer science students but also other the science background the students also to utilize the facilities as well as some computer techniques to learn and for utilization of various purpose. Here in the recent times, so almost all of you uh, thinking the regarding uh, machine learning, deep learning, Internet of Things, and blockchain technology. So like that, the so many the different words are observing because I am not a computer science background, but almost in all platforms or in internet or by mails. So the so many the programs, the latest developments in computer science are observing. So these are the very important for every the computer science engineering students to learn the deeply and utilize for various applications. So there is a flourishing future for the data science as the new generation of engineers and scientists are exposed to and start using it in their everyday life. The solution to clarify and distinguish the applications of the data science to physical based the disciplines and demonstrate the useful and game changing applications of data science in engineering and industrial applications is to develop a new generation of engineers and scientists that are well versed in the applications of data science. There is a constant demand for the data scientists in the field of healthcare and pharmaceuticals, telecommunications, internet industry, energy sector, automobile sector, and so on. Each field that requires the data scientists for various reasons, but the demand is the greater than ever. Some of the top careers in the field are data scientists, the machine learning engineers, machine learning scientists, applications architects, enterprise architects, data architects, infrastructure architects, data engineers, business intelligence developers, the statisticians, and the data analysts. Keeping in view of this, Department of Computer Science came forward and organizing this webinar for the students, the research scholars, and faculties of the computer science and those interested in the field of data science to provide insight and knowledge. Hope this webinar will help further in our research and career. And I request to the computer science department to collaborate with the national institutes, NITs, IITs, and other the deemed universities by taking the MOU for the conducting workshops, webinars, and the live the seminars physically and give the computer knowledge to each and every the students, not only students but also for the faculty members to learn the advanced topics or advanced techniques in computer science for development of the India also, because nowadays without the computer knowledge it is very difficult to survive. And each and every member, if you see the workers also using mobiles, and most of the uh, business people using the computers, not only a big business people, only the small shops also that consist of the laptops or the desktops. So with a meager knowledge, they are effectively utilizing for these techniques. So why don't you the give a knowledge to the students and other the people how to learn, how to utilize in application side, how to utilize these facilities for the development of their own businesses and etc. So I thanks to each and everybody by giving this opportunity. Thank you one and all.
Thank you, sir. Thank you very much for your enlightened speech. And definitely, we will make MOUs with reputed organizations and follow your as per your instructions. Thank you, sir. Thank you very much. Now, I request Vijay Kumari Madam to introduce the resource person, Dr. Saroj Kumar Biswas. Vijay Kumari Madam. Madam, I request Dr. R. Vijay Kumar Madam, please introduce the guest, our today's resource person, Dr. Saroj Kumar Biswas. Madam, please unmute your mic.
Hello.
Oh, madam, now it is working.
Okay, sir.
Thank you, madam.
Morning, everyone. Dr. Saroj Kumar Biswas received his BTech degree in Computer Science and Engineering from the Jalpaiguri Government Engineering College, MTech in Computer Science and Engineering from National Institute of Technical Teachers Training and Research, Kolkata, and PhD in Computer Science and Engineering from National Institute of Technology, Silchar. Dr. Biswas has been working as an assistant professor in Computer Science and Engineering Department, NIT, Silchar, since 2010. His research interest includes machine learning, artificial intelligence, pattern recognition, data mining, and image processing. 11 MTech students, excuse me, 11 MTech students have completed their dissertation under Dr. Biswas, and one student is presently carrying out his MTech dissertation. 7 PhD scholars are presently doing their PhD work under him, and 4 have completed. Dr. Biswas has completed one deity-sponsored R&D project and one NPIU World Bank sponsored R&D project. He has published total 40 international journals, including 23 science cited indexed, science SCI indexed journals in various reputed publication house worldwide, including Elsevier, IET, Springer, World Scientific, etc. I welcome Dr. Saroj Kumar Biswas to deliver his speech. Thank you.
Thank you, madam. Thank you. So let's start.
Please start, sir. Please start, sir.
Yeah, allow me to share my PPT reports. My PPT is visible to everybody? Hello? So PPT is visible to everybody or not?
Yes, sir. Yes, sir.
So thank you, everybody. First of all, I'd like to thank VC of Krishna University and other faculty members and the administrators, those who called me, invited me for this talk. And I would like to say thank the participants at the outset of the program, right? Thank you. So here, just in this talk, actually, I have given the title of the talk, and that is data science using machine learning, right? So here, actually, we're going to see if we want to make a data science model using machine learning, then how we can make and what are the phases and what are the issues, what are the things we need to do. That is our endeavor and objective here. Looking at how far can I complete within 1 hour, I could understand that I will make you understand, so that I'm going slow one by one and looking at how far can be completed. Slide is moving or not? My slide is moving or not? Please.
No, sir. No, it is not moving. Right.
Okay, fine. Now moving?
No, sir.
Not moving?
Not moving, sir. Now it is moving.
Just to tell me moving or not. These are moving. If moving, then I'll start.
Okay.
Moving. These are moving.
No. Now it is moving.
Yeah, fine. If my slide doesn't move, please report me so that I can move it, right?
Oh, okay.
So here already talked about what we're going to present in this presentation. First is we need to understand what is data science. Data science is a process that extracts knowledge and hidden patterns from huge amount of data. And the data can be structured, data can be unstructured, but it finds knowledge and insight from the data. And that knowledge can be used to sort out or to solve some intelligent program or intelligent task. Then we can say that process is data science. So if we summarize that, it says that if we can have a huge amount of data, from there our objective is to extend the knowledge. And that knowledge has to be used to solve some kind of problem. If we do, then we can say we are doing the data science of task. Now the questions comes, already talked about, we need to extract the knowledge from there, and knowledge can be used to solve the problems. So to extract this knowledge, we need to use certain kind of methods, processes, and algorithms. And those processes and algorithms we need to know, only then we can extract the knowledge. Now the questions, if we want to know these methods, processes, and algorithms, then which are the subjects we need to know? We need to know machine learning, traditional statistics, domain expertise, and basic mathematics. So if we talk about the 4 pillars on which data science is standing, then we can say they are the machine learning, traditional statistics, domain expertise, and basic mathematics. If we know all those things, only then we can be good data scientists, or we can have good knowledge about how to solve a data science problem. Now, one question will come to your mind that why we are talking about, or what is the fundamental goal of data science? The fundamental goal of data science is to make quicker and reliable solution to the decisions. Quicker, try to understand. If we don't use the data science, simply, if we use a conventional technique, we can make it, but I try to understand it can take time, longer time, and the solution may not be reliable. But whenever we are using data science, then we can make the decisions quicker, and the decisions or the conclusions where we're going to make, it is reliable. For that one, actually, we are looking for the data science. Now the next question comes, so if we use a data science, then which kind of problems we can solve? We can solve a different kind of problems. Nowadays, there is no limit of data science. Approximately, we can use everywhere the data science. But here, just I have noted some of the applications where data science are prominently used. Here, see the medical diagnosis we have written here, recommendation system, optimization problem, fraud detection, speech recognition, face recognitions, sign language recognitions, natural language processing, and in case of banking problem, then drug design, search engine, gaming, augmented reality, and many more where we can use data science. Fine. Next slide. Moving on. Not tell me my slide is moving or not. Please report me. Hello. My slide is
it's not moving, sir.
Yeah, you have told me this. Yeah, fine. So I have to like that, right? So here we talked about, right? Here. So
now it is moving. Yes. Okay.
So this is the definition of the data science already talked about, and these are the applications already talked about, right? These are the applications where we can use the data science. Fine. So now comes here. Whenever we talk about the data science, then one term comes that's called machine learning. Then what is the relationship between data science and machine learning? We need to know. Already talked about data science teaches machine learning with other subjects, and these are the traditional statistics, domain expertise, and basic mathematics, right? So now if you analyze from here, then we can say machine learning is a step or is a component to data science. So now data science can be seen as a solution to some problems where the machine learning can be seen as a component of that process. So you try to understand the difference between data science and machine learning. Machine learning does a part of data science, but data science is talking about the whole process to solve a problem. That is data science. Now, if we talk about the different components of the data science nowadays, then machine learning becomes the main component of data science. Now, you can have a question, if you don't know machine learning, can you solve the data science problem or not? Yes, we can solve using, say, statistical methods, using, say, basic programming paradigm, we can solve, but you try to understand, it takes huge time, longer time. In machine learning, the programs are developed, or the algorithms are developed in such a way that once we give the data, then automatically it finds a kind of solutions, and its finding is very much quicker. So that if in data science, if we use some machine learning, then we can make a reliable and a quicker decision. That's why nowadays, whenever we talk about data science, then the machine learning comes in association. Fine. In next slide, as already we talked about that machine learning is a main component of data science. Then we need to understand. We need to understand what is actually machine learning. But if you try to understand here, the definition is written. Then I'll explain with the example. Machine learning is programming computer to optimize a performance criterion using example data, past data. It says that we can have a huge past data or the example data. From this huge past data and example data, machine learning algorithm can be used so that the performance criteria can be improved. One of the performance criteria can be accuracy or it can be error. So if it is error, then objective would be to minimize the error. If the performance criteria is accuracy, then the objective would be to maximize the accuracy. Now the questions comes, how we can improve the accuracy using this statistical information, past data. Try to understand. Machine learning is talking about we can have like this kind of past data, and using this past data, we have to learn and we have to solve the problem. That's the objective. See here, one of the machine learning techniques I have given here, that's the neural network as a perceptron model. That I have taken two inputs here. You try to understand it's a kind of problem, say, for an example only, right? We have two inputs, one is BP, another one is heartbeat. And then we're finding the classifications here, whether somebody is suffering from diabetes or not. This is an example only for the illustration purpose. So this is yes, no kind of thing, right? So here we're putting the values for the first observations. We can put the values here. Then we can see the output. Now the questions, what can be the values of this W1, W2 kind of thing? These are the weights. Initially, these are called model parameters. So whenever we're talking about any machine learning algorithms, each and every machine learning algorithm must have some kind of model parameters. Our objective would be to optimize or to tune those model parameters. In case of neural network, the model parameters are or is weights only. So initially we can have a 0, 0 or any kind of weight, right? So simply we can give the data, then we can see what the system produces the output. Say the produced output is no, but here looking at the desired output is yes. So the network did some kind of mistake, and try to understand whenever some machine learning algorithm did some kind of mistake, only then some kind of learning is happened there. If there is no mistake, there is no learning in machine learning algorithm everywhere in case of all machine learning algorithms, right? So whenever some kind of mistake is there, then there will be certain kind of learning algorithm, right? Those things actually in machine learning are studied. So we can have a learning algorithm here. So based on this learning algorithm, we try to adjust the values of these weights because these are the model parameters. So in the second iteration, in the second observations, these weights are changed and these are given. Again, it looks whether it produces right its output or not. If right, then there is no learning. If there is a mistake, then there will be learning. In that way, actually, all the past input data are given here. Learning is done. And finally, when the problem is solved, or means whenever we get the optimal weights, W1, W2, so that the problem can be sorted out, then the learning is stopped. In that way, machine learning works actually. Fine. So in machine learning, the main objective is to train or to find the optimal value of the model parameters. Once we get the optimal parameters, using these optimal parameters, then we can find the best accuracy of the model. So now if we do the graphical representation of that, say we have a linear problem. This is a linear problem. We have white dots, 1, 2, 3. These are the white dots and these are the blue dots. Linear problem is one which can be solved by a single line, that is called linear problem. So we have here a linear problem, and here objective is to classify the white dot and the blue dot. That's the objective. But you try to understand, initially you don't know, because meanwhile you are looking and telling that if you make a line here, then the problem can be solved. But you try to understand, when it is given to the machine doesn't know anything. It knows only some kind of values. So initially we can give certain kind of weights here, and certain kind of line can be formed because it has the equation. That fundamental thing we are not going to talk about here. So based on that, it can make a line here initially based on the weights. So when the line becomes here, then we're looking at only three dots are classifying properly, and these are the misclassified. These are classified with the blue dots. If we have only this line, try to understand. So if you find the accuracy, then the accuracy becomes 50%. Say, so we are not satisfied with 50% accuracy. Then again, it is learned. Now the line is changed here. How? By changing these weights actually, right? So these things we can understand only if we have, say, bigger session and mathematical session, everything mathematical, then only you can understand how it does. But I'm telling superficially, right? So values will be changed, then here the line will come. Now if we find the accuracy, we're looking that most of the dots, white dots, stay classified properly, and these blue dots all are classified properly. So now the accuracy can be, say, 80%. When it shifts here, now again say, with 80%, we are not satisfied. So again, we'll learn when the line comes here, then we can say, yes, now this line or this classifier is talking about a line, you try to understand. It makes a boundary only. So one side of the boundary is talking about one class, and another side of the boundary is talking about another class. So whenever we get this kind of line, then we can see the problem is solved. So when the problem is solved, now 100% accuracy can be achieved, then the learning process can be stopped, right? So here, if the performance criteria is accuracy, so whenever the line is established here, then we can get 100% accuracy. Try to understand. So our performance criteria is optimized now. But I try to understand this performance criteria is optimized based on these model parameters. So whenever we're talking about machine learning can have certain kind of algorithms from the past statistical informations. The learning algorithm try to tune the model parameters like the weights here in case of neural network, and based on these model parameters, finally it produces or it can solve the problem. In that way, actually, machine learning works. Fine. Now, next question can be, this is the one of the definition which is the most prominently accepted by, say, all over the world, and this is the most, you can say, modern definition of machine learning, which is given by Tom Mitchell, and this is the definition I'm not going to talk about, because if I talk about, I will waste my time. Then I'll give you the slide, no problem here. Then we're coming here. Next questions. Then why machine learning? Everybody is talking about machine learning, right? You do that kind of thing. Somebody is working. So now the question is whether that problem cannot be solved using some conventional method. Yes, if the problem can be solved by the conventional method, then we don't need to use some machine learning. So for an example, if already we have certain kind of algorithms for the available, say, problems, then we don't need to use a machine learning. For an example, in case of sorting numbers, we have a number of sorting algorithms. That's why for sorting the numbers, we don't use a machine learning algorithms, right? But in some cases, we have a problem, but we don't have the algorithm to solve the problem. But fortunately, with the advent of efficient communications and technology, we are having huge amount of past historical information. And we know the problem we are going to solve, this kind of problem, but we don't have any ready algorithm for that. If the situation is like that, then machine learning algorithm is used. The learning algorithm is given there, the data is given, then automatically it learns and finds certain kind of solution from there. This is one of the situation. Another situation is that, again, using the past statistical information, if we use a conventional programming and if we use certain type of a statistical tool, then step by step also we can find certain kind of solution. But you try to understand, if we do those kind of things using, say, statistical methods, using, say, conventional programming methods, then it will take huge time. So if we have a huge past statistical information and we want to have a quicker and a reliable decision, then we need to use machine learning algorithms to learn. Fine, but it's not about data science. You try to understand. Data science is talking about a process which can solve a problem, the whole problem. So we're coming to that, right? So here, just now I have added, because as all you are talking about application, just now I have added here one of the applications of data science using machine learning. See here, earlier days, whenever we apply for a loan to a bank, then the data of a person's or the applicant was analyzed by you can say an expert, or it was done manually. But I try to understand nowadays this manual convention has gone. Now those things are done by certain kind of intelligent software, by expert system, right? So you have to give all your interests. The expert system has already ready machine learning algorithms. Then it can decide whether loan will be given to you or not. So loan will be given if the algorithm feels that you are a good payer. Then only if the algorithm, say, classify you as a bad payer, then the loan won't be given because you are the bad payer, right? So in that way, it can be classified whether loan would be granted or loan would not be granted. Yes, no, in terms of that. But you try to understand some developed countries, like say UK, Italy, America, where if you apply for a loan, if the loan is rejected, that is not sufficient. Then the bank has to explain why the loan is not granted. If these things come, then if we gives only yes and no, then this is not satisfactory result. So in such a case, we have to analyze the data and we have to find the rule for which the loan will be granted and for which the loan won't be granted. So whenever somebody applied for a loan, means he has given his personal information, different kind of informations, means what is age, whether he is doing job or not, how much salary, this kind of thing is given. Based on that, it churn out, it analyze, and it finds certain kind of rules. If our objective is to show the reason, then we need to use different kind of machine learning tools, and these tools are called white box technique. We're coming to discuss about those things. These are called white box techniques. Using those white box techniques, we can churn out and we can find certain kind of rules. So if you apply and these rules are not satisfied, then you are rejected. If these rules are satisfied, then you are accepted. So here we have taken a data set from the UCI repository, and this data set is called German data set, and it had 1,000 examples and observations. And out of 1,700 was a good payer and 300 was a bad payer. And total number of attributes was 20. And we did certain kind of, we devised a model, we devised a data science model using machine learning, and finally we got this result, right? And this result says that if credit history equals to existing page, these are the values already available in the database. You try to understand, whenever you want to make an applications of a data science, you must have past statistical information. So in the past statistical information, we had this kind of entry, and these were the values. So it says that the algorithm finds the rule finally after churning out, after analyzing the data. This is kind of rule. It says that if credit history equals the existing payer and credit amount less or equals to 12,204, then class good, means that he is a good payer. If this is true, then the person will be given loan. If it is not, then he is a bad payer, means the application would be rejected in that way, right? Now we have a question that yes, it will be working, that we found some kind of thing, some kind of rules. Based on that, some kind of decision can be taken. So now the expert system is ready. But you try to understand how this expert system is built. Now to build this expert system, we need to do a lot of things. Those things you have to know initially, only then you can apply. You can apply data science machine learning tool to find or to make some data science model to solve certain kind of problem. If you don't know all the parts and components, then your model will fail. Nobody will accept your model. So now we're coming to discuss about a data science model using some machine learning, which is not only for the research purpose, which is to solve some real life problem. So what kind of steps and what kind of things we need to do, we are coming to that one now. So I have here presenting here that this is a data science model. So whenever we want to make a data science model, the model which are working in the industry actually, all these phases are executed. So initially we can have a data set, right? I'm coming to discuss each and everything, data set. So after data set is available, then we have to prepare the data. That's called data preparations or data pre-processing. When the data is prepared or data pre-processing done, then we have to come for modeling and evaluation. In modeling and evaluation, we can have this kind of steps: model selection, model training, model evaluations. Now the first, we're coming here, the data preparations. You try to understand, to make a model, more than 50% time is given for preparing the data, because if the data preparation is good, then your model will be good. That model will be accepted by everybody, by the organizations. So in data preparations, we can have these kind of steps. Try to understand these kinds of steps are there. Not in every problem we need to use all those steps. Based on the data, based on the problem, we need to use these kind of steps. Now it is our duty to understand in which process, which kind of data pre-processing step should be employed. So in data pre-processing, we're having this kind of thing: removal of corrupted data, number one. Then we're handling missing values. Then we have data visualization, data exploration. Then outlier detection. class imbalance problem, feature analysis, and finally data normalizations. Whenever this is done, then the model is given, then this data is given for modeling and evaluation. So now we're coming one by one. So initially, because now we're going to make data science model, data scientist, right? Your registers are explained very nice way in say very organized way what is actually data science. So coming there actually, so initially have a data set. Data scientist is a bit different than the machine learning scientist or also machine learning kind of thing. Data scientist is the one who is responsible for the whole organization, who is responsible for taking certain kind of decision, who is responsible for taking certain kind of administrative decision, who is called a data scientist, not only learning. So to become a data scientist, you need to know all the things. So machine learning, you need to know the domain. You have to be domain expertise, right? You have to domain expert. You need to know basic basic statistics, right? Those things you have to know. So whenever certain kind of problem is going to be defined as a data scientist, you have to identify which kind of problem you're going to solve. That is your responsibility. So problem identification in the data set or the data scientist will do problem identifications. Now we have identified this kind of problem going to be solved. For example, so loan granted or loan not granted. This kind of problem is going to be solved, say. So this is the problem only. Now, second questions come, what kind of data would be required to solve this kind of problem? So data identification. These data identifications will be done only when the person is expert in the domain. Otherwise, he cannot identify the data which will be required to solve the problem. Right? After that, just we have identified these are the data, right? Then we have to do the feasibility study of the data, whether the data is available or not, whether we'll get the data or not. For an example, just we attempted certain kind of data, but in reality, we're looking that we are not able to collect this kind of data. Then the whole project will say collapse. So we have to study of the data, whether data will be available or not. So once it is done, then we have to start data acquisitions. Means we have to start collecting the data here. So this is about the data set. Once this data set is done, then we have to come for the data preparations. In the data preparations, we're coming here. Already talked about that the first step is what you see here in the data preparation. The first step is removal of corrupted data. So coming here, this is removal of corrupted data. Now the questions, what is the need? That removal of the corrupted data. What is the need of that? Initially, you try to understand what is actually corrupted data. Say here, we have a problem. See this table, try to understand this table, right? So we have a certain kind of attributes. We have age, we have weight, we have height, we have pressure, we have heartbeat, and there is certain kind of classification. So we are looking at the data. Here looking at the heartbeat, we can say 300, heartbeat 400 is a corrupted data. Why? Because these data are erroneous data, because these data not in format, these data not in range, because heartbeat cannot be 300, 400. So these kind of informations whenever we'll have, these are a kind of corrupted data. Fine. So this is one of the corrupted data. Similarly, we can have a different kind of corrupted data if the data is not in format. So you can see numerical format, but the data is available in say it's a categorical format. Say you need to have a continuous, but it is available in categorical format. So it is corrupted then. And so there can be certain kind of outliers, but we have different section for the outliers. We're going to talk about outliers there. Then we have a missing values. This also belongs to corrupted data, but we have a separate section for missing value here. So in this case, you try to understand if we have this kind of corrupted data, then what is the problem? So corrupted data is there in the data set. Then what is the problem? The problem is that if we train with the corrupted data, then the training won't be good. Then the model what we're going to devise won't be optimized. It won't be acceptable. So if we do the removal of corrupted data, then what does it do? It improves the quality of the training and reliability. It improves the quality of the training and reliability. So if the training of a model is good, it means what? The model will be accepted by the organizations to solve the problem. Fine. So you try to understand if we have a corrupted data, then we need to remove those kind of corrupted data. Next question, which kind of data can be corrupted? If you are very much interested in data science, you need to study on that, right? So we can have A, B, C, D. Already I have shown you one kind of corrupted data. I'm going to show all the corrupted data. But if you try to understand, if you're interested, you want to explore more, then you can see on the Google here. So here are different kind of books you can follow. So here we have A, B, C, D, E, and looking that D is a corrupted data. Then what we can do? We can remove this one, then we can keep A, B, C, D only in the data set, and then we can do further processing. Coming to the next one. After corrupted data, the database can have some missing values, right? What is actually the missing values? So we have a data. For example, this is a database. This is a very small database, right? So looking that here, we don't have the data. We don't have the data. We don't have the data. But you try to understand, if you talk about the data science, data is must. If data is not there, we cannot generalize. Model cannot be generalized in say good way. So whenever we have certain kind of missing data, that is not good. So we need to do the treatment of the missing values. Somehow these values has to be improved, or somehow this value has to be imputed, or some kind of treatment has to be given here. So if we do, or if we handle the missing values, then it improves quality of the training. Fine. So I already talked about the training is good, then the model is good. So how to handle if this kind of values are there, this kind of missing values we have in our database, then how we can do? What we can do? Yes, we can handle it in two categories, and these are called, one category is called, or one type is called deletion, another one is called data imputation. So coming to that one, what is deletion? Simply in deletion we have three kind of things here by which we can delete the data, or we can handle the missing values. So here, deleting rows, deleting columns, or deleting the pairwise deletion. So coming to the first one, deleting rows. So we are looking at in this database, right? In this database, we are looking at this data is missing here. So it's better to remove the whole examples from the training. So we remove this one and simply just we refine the database, and this will be a new database. So if you do the handling of the missing values like that, then it's called deleting rows. But here I'm just pointing out one point. Whenever we do such kind of thing, then automatically the size of the database is going to be reduced. And you try to understand machine learning model or the data science model is built over the data. So if the data size is reduced, then automatically the generalization capability of the model is going to be reduced. So if you're having number of such kind of missing values data, and if you say omit it from your database, the size of the database is going to be reduced. So be careful on that. So apart from that, we are having another kind of deletions, and here is talking about deleting the rows. And look, we are looking at here in this case, right? Here we have a missing values. Here we have a missing values. Here we have a missing value. So in number of places we are looking at missing values are there. So now if we want to delete the rows, so how many rows we are going to delete? 1, 2, 3. So if we delete the 3, then automatically this database size is going to be reduced. So it's wiser what? So instead of these observations or the rows, we're going to delete the whole columns from here. So if we delete this one, then finally the refined database becomes like this. And now this data set can be taken for further analysis. And now if we do, so this is done. And if we do the pairwise, it says that pairwise means say we have 1, 2, 3, and 3 independent parameters and 1 dependent parameter. Now say we are interested in doing the analysis of with 2 dependent parameters and 2 independent parameters and 1 dependent parameters, and they are BP and heartbeat. We are not going to consider the weight. As we are not going to consider the weight, that's why we are not going to treat this one. You try to understand. In case of pairwise, we need to understand which kind of attributes we need for the analysis, and we will be concentrating only for those kind of attributes. So here our objective is to deal with only BP and heartbeat. So we have taken BP and heartbeat, and from here we have seen here we don't have the data, so we omitted this one. Here we don't have the omitted this one. Here we don't have omitted this one. But you try to understand, here we don't have, but we didn't do any kind of treatment here, because now we are not going to do certain kind of analysis with this column. So if we do in that way, so that is called pairwise actually, deletion. So deletion is one way. The other way is the data imputation. Data imputation means the creating the data artificially. That is called data imputation. So here actually initially we didn't have any kind of data. So missing value is here. So now we're not going to delete state. We are going to do data imputations. Means we are going to create the data here. So now the question is how this data can be created. Data can be imputed in different techniques. These are the techniques. We can use a mean here, we can use median, we can mode, we can linear interpolations, linear regressions, KNN, and different kind of machine learning algorithms. And many people are working and doing their PhD in data imputations, because you can propose some kind of new algorithms for data imputations, right? So if we talk about some standard tool by which the data imputation is done, so these are the standard tools. So based on the problem, based on the data, you have to use one of the standard tools, right? If you do simply the data imputations, or if you are doing the research, then you have to devise new kind of algorithm for the data imputation here. So for example, we're going to impute the data using some mean here. So how we can going to find the value of this one? We are going to find the mean of this column, except this value. So we have written here, this is 70, 70, 65, 65, 59, 55, like that. We have taken all the values here, and we found here the mean value, and the mean becomes 67. Now this 67 becomes the imputed value for this missing value. So in that way, actually imputation can be done. But again, one thing can be pointed out here, there imputation is not again suggested, because whenever you are going to do imputation, it means what? You are going to create some artificial data. This is not the actual data. Fine. So again, we have a cap here also. So using also mode, if it is a categorical data, then instead say mean, we can use a KNN, or we can use a mode like that, right? So for an example, we are going to here say KNN for input the data, and here the value of K is taken for. You try to understand KNN as a machine learning algorithm, and where the value of K is the tunable parameter, means you have to consider how much value you are going to take. So now say we have taken here the value of K, that is 4. So if you take the value of K equals to 4, then this. Out of this one, which one is the majority? This is yes, this is no. This is yes, this is no. Which one is the majority? Yes is the majority. That's why the value of this missing data would be imputed by Y, right? If it is categorical. So in that way, actually, based on the data, based on the nature of the data and the techniques which are available, as a domain expert, you have to decide which kind of technique you are going to adopt, right? So in that way, we can handle the missing values. After handling the missing values, we have a next part or next step that is called data visualization and data exploration. What is that actually? Means here in this case, the data has to be explored. A different kind of, say, statistical tool can be used here. Different kind of characteristics, underlying behavior of the data can be analyzed by some numerical computations or also by the visual tool. So what does it do actually? If we do data visualization and data exploration, then how does it help us? It helps, I have written here, it helps to understand underlying behavior of the data, which helps to take right step in data preparations and modeling. Because in data preparation, we need to take different kind of decisions, right? As we are looking from the outer view or the black box view of a model, that's we're thinking that things are simple, but you try to understand when you want to do mathematically, right? If you want to understand mathematically, things are not so simple. Different kind of situation will come. So in this situation, which kind of methods will be used? So that one can be solved if we know the characteristics of data. So if we do the data visualization and exploration, whenever certain kind of situation will come, that situation can be sorted out very easily based on the characteristics of the data. Now coming how we do data exploration and visualization. The data explorations can be done. There can be number of techniques, number of measures, right? Just we have taken here the 3 measures, and these are the statistical measures. Written here, this is the mean, this is the median, and this is the variance. Using the mean and median, what we can find? We can find the central tendency of the data. And by variance, we can understand the spread of the data and how it spreads. Clear? Now coming here, say we have observation. Try to understand right mathematically, right? We have an observation here. Means we have a list or we have an attribute here. And the attribute having this kind of values: 21, 89, 37, 34, 67, 97. So if we find the mean of this one, then mean becomes 61.4. And if we find the median, it becomes 67 actually, right? Now, if there is no big deviation, we are looking at there is no big deviation, right? It's a small deviation kind of thing, right? So if this is not, if there is no big deviation between mean and median, then we can say data are uniformly distributed. Data are uniformly distributed because there is no big deviation between mean and median. Fine. Now, if there is a big difference between mean and median, which means what? The data are very much, you can say there is no uniform distribution. That's why whenever somebody talks about the salary package of a college or company kind of thing, then the mean doesn't work, only you try to understand, right? So you have to find also median. So then you have to find whether there is a big difference or not. If there is less difference, then you can say, oh, okay, the uniformly distributed means everybody is getting certain kind of thing. Means some kind of thing is there. So we can understand the nature of the data by mean and median. So they're coming here, one more instance is here. So we have a state of sorted list here, right? So here the values are 21. We have here 20, 23, 24, 25, 84, 76, 50, like that, right? So this is our observation now. Now if we find the mean becomes 46.1. And so median how much? 25. So if there is a big deviation between mean and median, although you talked about the data are not uniformly distributed, it is not uniformly distributed, and there can be a certainty that data are concentrated either in the lower range or in the upper range. Data are concentrated in the lower range or the upper range because there is a big deviation between mean and median. So see here, in this case, the data are very much concentrated to the lower region. So lower is a 20, and here we have a much data which are very much concentrated to 20. So if this kind of thing is there, then we can have a big difference between mean and median. So if so, then we can understand, yeah, data concentration is either either lower or either in upper, means data are not uniformly distributed. Now we have another instance here, right? So you try to understand, if we know all those things, then we can understand the behavior of the data set. By understanding the behavior of the data set, number of decision problems during the design of the model we can take. Because arbitrarily, whenever somebody works for the data science, people jump directly, I will work with decision tree, but I don't know the background, I don't know the characteristics of my data set. Directly I jump, I will work with neural network. But if you try to understand, whenever we have the problem, we need to analyze it, and which one fits best, that one we need to choose for particular problem, to solve particular problem, right? So that's why this exploration and data visualization is required. Now see here, we have this kind of thing, right? One of the items whose value is 200, and all of the item 21, 89, 34, 67 kind of thing, right? So here we are finding mean. Mean is 82.2, and if you find a median, it becomes 67. So there is a big deviation between mean and median. So whenever there is a big deviation between mean and median, there is a chance that there can be outlier. So if you see carefully the whole set of observations, so that this observation, the item 1 is having how much? 21, 89, 37, 67, and suddenly here 200. So 200 means what? It can be outlier. You try to understand, because this value is not associated, is not very close to the mass of the items. So we have an outlier here. So you try to understand, whenever we can have a big deviation between mean and median, so there is a chance that the data set can have some outlier. So whenever we can understand that data set is having outlier, then before processing the model using any machine learning classifier, so outlier detection has to be done. Because if there is outlier, if the training is done, the training won't be good. Try to understand. That's why actually you do data exploration kind of thing here. So simply here I have one more. So if I talk all those things, then I cannot finish up. So here again we have a number of things. In that way, data exploration kind of thing is done. After data explorations, we are coming to data visualization. What is that actually? Data visualization. Data visualization helps in understanding the distribution of a numeric data in series of interval. So if you do, then what is the benefit? The benefit of that is that it gives us quick understanding of the data. For an example, we have this kind of values here, right, in the database for certain, you can say, feature. So here we can have 20 kind of things, right? But you try to understand, in say, when we solve certain kind of problem, we can have 1,000 and 1,000 observations. So if you want to make certain kind of quick observations. So by looking at the data, we cannot understand. So for that one, we need to have a histogram or some kind of visualization tool. So one of the visualization tool is the histogram. So here, what I have done a program here where just it finds how many items are there in between 30 to 40. How many are there 40 to 50? How many 50 to 60? How many 60 to 70? How many 70 to 80? Kind of thing, right? We have made a pictorial representation here. So simply if you see here, then we can conclude, yeah, we didn't say 30 to 41. We didn't say 40 to 54 kind of thing. So we can have a quick understanding of the data if we make or if we use certain kind of visual data visualization tool. This is one. Another thing is that here, try to understand, right? I have taken two data sets from the UCI repository, and I made say a histogram for the class levels, means how many observations belong to which class. So I have taken this is the iris problem. In the iris problem, there are three classes: iris setosa, iris versicolor, iris virginica. So I found that how many observations belong to this iris. I mean, how many classes are there in this class? How many observations are in this class? How many observations are in this class? I have looked at, so in all of the cases is around 50-50 kind of thing, or 50-50, right? So if we have a 50-50-50, then this kind of database is called balanced database. Means all kind of classes are equally distributed there, fine? And now I have taken on thyroid. This is thyroid dataset. So in thyroid, two classes are there, 0 and 1. So in this class, 0 class probably, or one class is around more than 350, and another class is more than 50 only. This is one class is having this number of observations, and another class is having this number of observations. So from here, we can understand that the data set is not balanced. If the data set is not balanced, now if this data set is given for the training purpose, then the training of the algorithm won't be generalized and won't be reliable, because the model is going to be biased to the majority class. So whenever we can analyze and we can see this kind of situation is there, then we need to give certain kind of treatment for the imbalanced data set. So by data visualization, we can understand the behavior. Based on the behavior, we can use or we can give certain kind of treatment. Here we have another kind of visualization tool that is called box plot. What does it do? This is an effective, you see it here, just I'm reading it out, an effective mechanism to get a one-shot view and understand the nature of the data. So if you make a box plot, then we can understand the nature of the data. One-dimensional data, you try, there can be number of dimensions, but it talks about the only one dimension at a time. So see here, in case of box plot, I had a 4-dimensional data because it was a iris data set. That's why this was a kind of say snapshot of the box plot analysis. After that, I have done it for one attribute only, this attribute only. Just I have done the analysis, and this kind of box plot has come up. So what it talks about, what it says, in box plot, we can have the statistical summary. This summary in 5 parameters, and these parameters are minimum, first quartile, median, third quartile, and maximum. This one is called minimum. This one first quartile. This is median, third quartile, and maximum. And whenever we do say box plot analysis, if some items are beyond the minimum or beyond the maximum, then we can say they are the outliers. So if you analyze the iris data set with the second attribute, then you can see that there are 4 means samples of the patterns which are treated as outliers. As we have seen, as after doing the box plot analysis, we found that there are 4 outliers. So before executing or before training the model with iris dataset, our endeavor would be to sort out or to remove these kind of outliers. So if you remove this kind of outliers, then the training will be good. After that it comes, that is called data visualization, and we have done it here using say scatter plot. So it talks about till now whatever we have done. This is done for one attribute or one dimensional analysis. Means we can take one dimension and then we can analyze on it. But I try to understand whenever it comes to which one is scatter plot, it does the analysis of 2 dimensions. It finds the relationship between 2 variables. So we can have a variables here, we can have another variables here. So now we can plot here, then we can see that whether their relationship is linear or non-linear. So from here we can see it's a linear, it has a kind of linear relationship. So if it is depicted that there is a kind of linear relationship, so if it becomes a problem, then this problem can be sorted out using some linear machine learning tool. Because there are some linear machine learning tool, there are some non-linear machine learning tool. So if the scatter plot, or if the distribution is not linear, but the relationship is not linear, we can understand by the graph, right? You have to understand all those terms if you want to do data science, if you want to know machine learning. You need to know, understand all those things mathematically. So if you find that the relationship is not linear, there's a kind of non-linear, then you have to use a non-linear tool here. Fine. So after data visualization and data exploration, you try to understand this part is not over yet. Many things are there. The data visualization, data exploration is a separate topic and a subject also. Fine, because you have to understand the nature of the data. Only then you can apply different kind of tools to solve the problem. Otherwise, not. So after this one, after data visualization, data explorations, we're coming here. That is called outlier detection. Fine. So first of all, we need to understand what is outliers. Outliers far from the rest of the observations or center of the mass of the observations. Means if we have certain kind of observations which are very far from the center of the mass or most of the observation of the space or the problem space, then we can say those observations are outliers. So here you can see one example. So these are the patterns or observations. All those patterns are very much close and they are looking very much normal. But if we talk about this data, say this data is very far from this, and also from the center of the mass. Similarly for this, similarly for this. So if we have this kind of data, then those data are treated as the outliers. Now the questions, if outliers are there in our database, then what is the problem? The problem is that it can result, means the outliers can result in a poor fit and lower predictive modeling performance. Means the model what we are going to devise, the performance won't be up to the mark because in your data sets you are having outliers. Clear? So now if outliers are detected and removed, then what kind of benefit we can get? We can feed the data properly and enhance the performance of the model. So the model performance will be enhanced if the outlier detection is done properly. Clear? And now again one line. Histogram or scatter plots can be used for 1 or 2 dimensional data. We can do this outlier detection using histogram and scatter plot, but you try to understand these are only applicable if we have 1-dimensional or 2-dimensional data. But you try to understand nowadays we have a multi-dimensional data set or high-dimensional data set. So whenever we have a high-dimensional data set, then this kind of simple statistical method cannot identify the outliers. Then we need to use some advanced statistical tool or the machine learning algorithm to find the outliers. Once they are found, then they can be removed from the data set. So coming here to talk about some of the outlier detection technique. The first one is called isolation forest. It's a tree-based outlier detection technique. And it is believed that whenever we have the data, all normal data are having the similar kind of attribute values. So whenever we have certain kind of data or the observation in the database whose attribute values are totally different than others, then they are the outliers. This working principle is applied here and finds the depth of the tree, and based on the depth of the tree, actually the outliers are detected using isolation forest. Fine, it's a very common and very effective, that is called isolation forest. Again, I'm telling one thing, those who didn't do, they're looking that in isolation forest, if you see the mathematical part is really very huge. Many things are there, but you try to understand, if you want to implement in Python, just you need to use only the isolation forest, one module, nothing more than that. Simply use isolation forest, then it will work. You can find the data set, and then data set can be used for the machine learning classifier. Simply it can be done. Simply it can be done. Those who didn't do, or those who didn't have the experience in Python, then they cannot understand. But things are very simple. But if you want to do mathematically understand, and basically if somebody wants to do code using say basic Python or using say basic C programming, then they need to know all the mathematics, then only they can do. But there are a number of packages in Python, right? By that we can solve this kind of problem simply. After that, we have this minimum covariance determinant, then local outlier factors. This is one of the prominent techniques, local outlier factor. And after that, we have one class SVM. All are having certain kind of detail, but I'm not going to detail. I have detail and mathematical detail, all the things with me. But here to summarize within 1 hour, just I have written some of the things, but still I'm looking that it's not possible to talk about. But just you know that these are the techniques by which we can do, which one we can find the outliers from the data set. Okay. So after that, here now some questions comes now. Yeah. After that, we have class imbalance problem. Class imbalance problem. What is that? See here, we have a problem, and it's a linear problem. Already talked about if a problem can be solved you by a line, then this problem is called a linear problem. So we have here a linear problem. Fine. So here we have a black dots. This is one class, and we have another class that is blue dot. They are the another class. Try to understand, right? So if you count here, how many blue dots are here? 1, 2, 3, 4, 5, 6, 7, 10. If you count here, how many? 20. So now the ratio is 1:2. So number of blue dot is less, number of black dot is more. So now if this database is given to any one of the machine learning algorithms, so when the training would be done, then the classifier would be biased towards the black dot, then the blue dot. Why? The thing is that already talked about the algorithm is in the first 2-3 slides we have seen that the algorithm is trained or the classifier is made based on the data. So whenever the data is misclassified, some kind of learning is done there. Fine. So if we have a 20 black and 10 blue, so it is expected that the number of black dots which would be misclassified by the classifier during the initial phase would be more than the blue dot. So the learning chances of the learning of the classifier would be more for the black dot. More times it would be learned. Whenever one black dot is misclassified, some kind of learning would be there. And whenever some blue dot is misclassified, then some kind of learning would be there. So misclassification of blue dot would be lesser than the black dot because number of black dot is more during training. So when the model is trained, this model will have a higher impact of this black dot. Try to understand, right? So once this kind of model is devised, and now this model has to be applied to the new data. So whenever some new data will come, then this classifier will try to classify this new data to the black dot because the classifier, what we have made here, is a bit biased, and that is biased towards the black dot. So if we have this kind of database, you try to, whenever we have this kind of database, if the training is done, that training is a biased training. So if we have a biasness in the database, then it doesn't work well. So what we need to do, what we can do, you try to understand whenever we have which one class imbalance problem that it biases towards the majority class. If it biases towards the majority class, then finally the performance of the classifier will drop. So fortunately, now the question how we can handle. Yes, we can handle. Fortunately, we're having number of machine learning algorithms by which we can sort out this kind of problem, this class imbalance problem. So here we have especially those who are much popular. There are 3 approaches to handle the class imbalance problem. One is called sampling, then say algorithmic, then say ensembling. These are the approaches. Now this sampling approach, what actually we do in sampling approach? In sampling approach, either we increase the number of instances or we decrease the number of instances. Fine, that is done in say sampling method. Based on that, the sampling method is categorized into 2 methods, 2 approaches. One is called undersampling and another one is called oversampling. What is actually undersampling? Undersampling reduces majority class instances, right? So that some kind of balanceness can be restored in the database. If we talk about here, so here we have a 20, here 10. So what we can do? We can remove the 10 black dots from here so that we can keep here only 10 black dot and 10 blue dots. So if we have a 10, 10, then we can say now the database is balanced. Clear? So if we do like that, then that is called undersampling. Means we are reducing the majority class instances. So how we can do? There are a number of undersampling techniques. And the people are working there, those who are the data scientists, they are very much keen in this area. So number of algorithms are there. Random undersampling, atomic link based undersampling, condensed nearest neighbor undersampling, and the near miss. Number of undersampling methods are there. These are very old, right? These are very old. There are a number of new algorithms are there. And people are working there also, those who are working in data science. So apart from this undersampling, we have another one that is called oversampling. What does it do actually? It increases the minority class instances. If we talk about with respect to this problem, then we can say we have a 10 here, 20 here. So what we can do, we can increase here more 10. So here 20, if we increase here more 10, that is become 20. So 20, 20. So now the balance list is now the balance of the data set is restored. That approach is called oversampling. Similarly, there are a number of techniques by which we can do oversampling. These are the ROS, SMOD, borderline SMOD, stable SMOD, ERASIN. There are a number of new techniques are there. So those who are intended to do or to pursue the research, they can work here, right? Undersampling, oversampling, right? If you are interested, you can talk to me also, no problem. I'm very much open. I'm very much dedicated for the research, right? If somebody is interested. Apart from this sampling, then we have an algorithmic approach. What it does actually, it does what I'm not going to take you much time. I know that I crossed my limit. So here what does actually, just I'm telling this one, it does what? It actually changes the cost function, because whenever a learning thing is done, whenever a pattern is misclassified, then there is a kind of, say, learning. So during learning, so misclassification cost is given. So higher misclassification cost is given for the minority class, because this minority class gets less chance in the you can say in the learning. That's why whenever some minority class is, say, misclassified or some mistake is done here, then during training, the impact of that would be given more. Means the weight during the during the learning would be given more for the minority class, so that some kind of balances can be drawn up here. That kind of approach is called algorithmic approach. And then there is some ensembling approach which merges this undersampling, oversampling with the algorithmic approaches and produces very good promising results. And people are working right now in the ensembling approach to sort out class imbalance problem. Not going to discuss, just showing you. After that, we need to do feature selection, or that is called feature engineering. We need to do feature engineering, right? Because number of things are there in the feature engineering. You need to do in detail. One topic is there for feature engineering. And then after feature engineering, data normalization we need to do. But I try to understand, always data normalization is not required. Always not required. For all techniques, it is also not required, right? Analysis there, right? After normalization, we need to do some model selection. Directly we jump, and in model selections, I have classified all those things. What kind of algorithms are there? Supervised, based on the learning paradigms, the machine learning algorithms are classified into supervised, unsupervised, reinforcement. These are the classification. These are the tasks, and these are the algorithms for the supervised learning, and these are the algorithm for unsupervised. How the training is done in the supervised learning. This slide is included here. Then these are the algorithm for unsupervised learning, and here these are the algorithm for reinforcement learning. And after that, we have here how the model can be selected, because there are a number of algorithms for the classification. For a particular problem, which kind of method or which kind of algorithm should be chosen, here we have the discussion for that. Actually, not going to discuss, don't have time. Then we have a model training. So generally people what do, they generally take 80% for training, 20% for testing. And this method is called holdout method, but this method is having certain kind of problem. To sort out this problem, the k-fold cross validation is there. In the k-fold cross validation, this is the working principle. The whole working principle is described here. Again, in k-fold cross validations, we're having certain kind of problem. If the data set is very small, then k-fold cross validation cannot be done. To overcome that problem, actually, the bootstrapping came in existence. This is another kind of paradigm, right? And after that, what to do with model evaluations? If it's a classification problem, then you need to make a confusion matrix. With example, I have explained nicely here, but due to paucity time, we cannot do. So for the classification, we need to find, say, accuracy, right? For which one? For say regression problem, we need to find R squared. For say clustering problem, we need to find different kind of performance measure, and they are called internal evaluation. One is, and then the coefficient is called relative coefficient or the relative width, and second one is called purity. Like that actually. Thank you everybody. Up to here I wanted to discuss. Fine. Thereafter in my slide I have different kind of learning algorithms in detail mathematically, right? So in detail mathematically, if I discuss one of the algorithm, then it takes the whole time. That's why I didn't incorporate, but I wanted to give you one view. If you want to make a data science model, then which kind of steps you need to do so that you can claim that really I have designed or I have made one data science model which can sort out some problem in reality. Thank you everybody. Thank you.
Thank you, sir. So, sir, you have discussed about various data science models, sir, and you have enlightened us in various areas of the data science, including the machine learning techniques and all. So, thank you very much, sir. And now I request Dr. Vijay Kumar Garu, Head Department of Computer Science, to introduce Dr. Asadi Srinivasulu Garu, Bluecrest University, Liberia.
So during my session, anybody has any questions, then you can put the questions because I may not continue. I think I have another meeting, so I can join also here after that. But I don't know. So how far can I? How far it will take another meeting?
Sure, sir.
Any question, anybody?
No query, sir. Madam, please continue.
Okay, thank you, thank you.
Okay, sir. Sir, am I audible, sir? Krishna, sir?
Yes, sir. Yes, madam.
Okay, sir. Dr. Asadi Srinivasulu received BTech degree in Computer Science and Engineering from Sri Venkateswara University, Tirupati, MTech in Intelligent Systems from Indian Institute of Information Technology, Allahabad, Uttar Pradesh, and PhD from JNTU, Anantapur, India. Dr. Srinivasulu is currently working as Head Research and Professor of Information Technology at Bluecrest University, Liberia. He has 19 years of teaching and industrial experience. He served as the head Department of Information Technology, SV College of Engineering during 2007 and 2009. His area of interests include data science, big data analytics, data mining, artificial intelligence, etc. He is an editorial board member of SCIERA, Journal of Computer Science. He also is an editorial board member of several reputed and peer-reviewed international journals. Dr. Srinivasulu has guided 1 PhD, 14 MTech students, 28 BTech students, and 5 more students are pursuing PhD under him. He has published more than 110 papers, including several SCI indexed, Scopus indexed, Web of Science indexed, etc. Sir has published 3 textbooks, and he also has 2 DST SERB seminar grants worth 1 lakh rupees and 9 lakh rupees. Dr. Srinivasulu also received so many awards like Bharata Vidya Ratan, a national award from International Business Council Delhi in 2018, Best IT Teacher of the Year award from ITAP and Tutors Pride Hyderabad, Best Mentorship Award from IBM TGMC Challenge Contest and Microsoft in 2011 and 12, Best SPOC of NPTEL Swayam, Best SPOC of STP IIT Bombay in 2019, Best Mentor Internship Award from Internshala AICTE Delhi in 2019. Dr. Srinivasulu has visited many countries like Malaysia, Thailand, Singapore, and Liberia. I request Dr. Asadi Srinivasulu Garu to deliver his lecture. Please welcome, sir.
Hello, madam. My voice is audible?
Yes, sir. Yes, sir. You can continue.
Hello?
Sir, you are audible, sir.
Yes.
Yes, sir, you are audible.
Yeah, my
Sir, visible, sir.
screen is visible, madam?
Yes, sir. Yes, sir.
Okay, sir. Today I would like to explain data science applications. Various applications I have executed real-time COVID-19 virus detection, machine learning algorithms, and the same way COVID-19 strain virus detection, and as well as Ebola virus detection and prostate, breast, and lung cancer detection with the help of learning and deep learning techniques. So thanks to my earlier speaker, he has given the information about the model selection, how to and data science models. So to my topic, I would like to know what is happening in this world. If you are connected to the internet, what is happening to the in this world? Let me check through practicals. So if you see, use sir, my hello, sir. Sir, my
Sir,
screen is visible, sir.
sir, screen is visible, sir, but there is some disturbance with your audio, sir.
Sir,
It is being breaked up.
now my screen is visible, sir.
Yes, sir.
Right
Screen is visible, sir.
Yeah.
But the audio is breaking
So
up.
if you type www.internetlive. Yes, sir. Yes, sir. Yes, sir. If you type internetlives.com, if you type internet live, hello, sir. Yeah. Now see how the data is how many users are connected to in this world, and storing how many internet users are connected to right now in this. You can see the number. See how many users are connected to the internet.
Excuse me, sir. Excuse me. Sir, Srinivasulu, sir.
Sir, hello, sir.
Your voice is
Sir, my voice is audible, sir?
not audible, sir. Some disturbance is there, sir, in your audio.
Oh, please now, sir. Now my yeah. So now I'm sharing.
Sir, we are unable to hear your voice.
my screen. Please check now, sir.
Still same disturbance, sir.
Hello, sir. My voice is audible. Hello.
Yes, sir. It is audible now, sir. You can continue.
Yeah. So after typing internet live statistics, just a minute, sir. Again, I'm sharing. Sir, just check all of you. My screen is visible now.
Sir, it is visible now, sir. You
Yes,
can
sir.
continue.
Yeah. Please, my dear participants and my dear respected faculty and my dear students, if you see if you type internet live stats, see how the numbers are rapidly increasing. You can't read such a number, huge number, internet users in this world. Total number of websites opened now in this second. How many emails sent today? Google searches, blog posts, tweets. If you see how many videos viewed at YouTube and photos uploaded. See, Facebook active users, the number is changing rapidly. That means where the data is storing, how the data is storing, and how many servers are required, where the data is storing, how many servers are required. So you may get doubt. The reason behind in this one, we are using cloud data centers in order to store a huge volume of data. Okay, so today I would like to explain the contents of Introduction to Data Science, Statistics, basic concepts with three techniques I am going to execute, like linear regression, nonlinear regression, and logistic regression. Then what are the artificial intelligence top 10 algorithms, data mining concepts with top 10 softwares and top 10 techniques and machine learning techniques and deep learning techniques. After that, I'm going to execute 6 database virus prediction detection applications. I'm going to execute, and the prerequisition of data science. If you see the prerequisition, data is a raw material. Data can be a fact or image or anything can be a raw material. Once we are processing the data is called information. Collection of interrelated data is called a database. To manage the database, we are using various relational databases and relational-less databases such as SQL, MySQL, Teradata, MS Access, Hive, HBase, various tools we are using, Mongo database. Combination of data plus DBMS, we used to call it as a database system. Subset of data warehousing. Subset of storing of small amount of data in the server is called OLAP or data mart. Collection of data marts and storing huge volume of data in the data center is called data warehousing. Online analytical processing is also called as a data warehousing. Once we are storing huge volume of data, why we are using we are storing a huge volume of data in order to extract meaningful interested patterns from the large volume of data. So with the help of various techniques like classification, clustering, association, rule mining, outlier detection. So then comes to the big data analytics. There are problems like volume, what is the size of the data we are handling, and variety, what type of file we are handling, and velocity, data in motion, the file we are downloading, uploading. So there are a few more V's like visibility, viscosity, value, validity, etc. This is about big data analytics. To process the big data sets, we are using various tools like Hadoop and Spark. Then comes to the data science. Data science is the process of extracting meaningful interested patterns. We are extracting insights from the huge volume of data with the help of scientific methods, process, algorithms, and systems. Then what is the technical jargon of this image? If you see this image,
Sir, your data is not, your slide is not moving actually.
Sir, my screen is not visible. Hello, sir.
It was not moving earlier because you just you were just with one slide. I think.
One second, sir. Again, I am sharing. Now my screen is visible, sir. Hello, sir. My screen is visible.
Yes, sir, it is visible.
Yes, sir. So, what is the technical jargon of this image? Can anyone give the answer for this? What is the technical jargon of this image, logo? Everything we have incorporated in this image: programming, solving, knowledge, process, structure, system. Everything is there. Technology, process, everything is there. The technical jargon of this image is called word cloud. The technical jargon of this image is word cloud. Hello, sir. My screen is visible, sir. Hello,
Sir, your screen is visible, but it's not moving. You do one thing, sir. You don't make slideshow. You don't make slideshow. Just you with say 100% this one remove from the slideshow, and then you just move your slide. Yeah, now that you just move your slides, then it will be moving. I think.
Okay, sir. So next, how we are measuring the data in data science? If you see the normal range and big data range, see the computer understands only ones and zeros. So 1 bit is equal to 0 or 1, 4 bits is equal to 1 nibble, 8 bits is equal to 1 byte, 4 bytes is equal to 1 word, 4 words is equal to 1024 bytes. 1024 bytes is equal to 1 kilobyte, 1024 kilobytes is equal to megabyte, after gigabyte, terabyte, petabyte, hexabyte, octabyte, zettabytes. See, up to zettabyte, if you see the robo movie, before robo movie, we don't know how we are measuring the huge volume of data. After robo movie only we got, there are the numerous terminology, how we are measuring the data in computer science, in data science. So, hi, I'm robo. My speed is 1 terabytes. My memory is 1 zettabyte. 1024 octabyte is equal to 1 zettabyte. 1024 ZB is equal to 1 YB, yottabyte. 1024 yottabyte is equal to 1 brontobyte. 1024 brontobyte is equal to 1 geobyte, not JIO geobyte. Please keep in mind, my dear friends. So yesterday night I have searched, there are 2 more terminology. Those are the brontobyte and 1 geobyte. This is the way, if you ask me after geobyte, there is no terminology. 1024 geobyte is equal to infinity. This is the way we are measuring the huge volume of data. If you take normal range and big data range, if you take kilobytes and terabytes, you know, kilobyte 10 power 3, terabyte 10 power 12. If you take in big data range, petabyte is 10 power 15 and yottabyte is 10 power 24. If you take 1 brontobyte 10 power 27 and 1 geobyte 10 power 30. This is the way we are measuring the huge volume of data. Data is central to data science. Without data, there is no database applications. There is no data science applications. Data are characteristics or information, usually numeric, that are collected through observation. We are collecting huge volume of data from observational data, actionable data, and a huge volume of data. With the help of data science collection tools, we are collecting data from through interviews, from observations, from surveys, from usage of data, focus groups. This is the way we are collecting the huge volume of data. So these are the various sources we are collecting the data. Databases and legacy documents. Through media data we are collecting, through cloud databases we are collecting, through web data we are collecting the data, and Internet of Things we are collecting the data, social network profiles we are collecting the data, and we are doing analytics. Social influencers, activity generated data, and data warehouse appliances, and network and in-stream monitoring technologies like YouTube data, time series data. We are collecting various data types through various sources. And like I have explained, online forums we are collecting, groups we are collecting, web survey chat we are collecting, online communication, and in-depth interviews. With that one, we are collecting a huge volume of data and storing in the data centers. What is data center? Collection of high integrated servers at one place is called data centers. The big giants like Microsoft, Google, Facebook, they are having their own data centers. If you take Microsoft MS Azure, they are having their own cloud, and the backbone of cloud is data center and virtualization. Cloud is nothing but internet-based technology. Data center is nothing but collection of high integrated servers, and we are storing huge volume of data in the data center. And virtualization is the ability to perform multiple tasks in a single system with help of VMware, hypervisor, Zen, virtual iron. We are creating n number of virtual machines. The best consumer of cloud computing is a Gmail. So whenever you are connecting to the Gmail, instantly you are getting access because you are the instance of that Gmail server. Gmail server is located at USA and remote location. You are accessing that service 24/7. So we are getting various sources, a large volume of data from various data centers. Then coming to the beautiful definition of data science. Data science is also called as a data-driven science. It is an interdisciplinary subject. It is extracting insights. It is a process of extracting insights and interested patterns from the huge volume of data with the help of scientific methods, processes, algorithms, and technologies. And so it is a multidisciplinary subject because we are using scientific thinking, statistical methods, computer engineering, and innovative technologies. So what is data science? Where we are using this data science? Why we are using data science? Just now I have told you data science is also called as a knowledge discovery database. First step, we are collecting the huge volume of the data from various sources. As a programmer, you are eliminating as an analyst, you are eliminating the noisy data with the help of pre-processing mechanisms, like pre-processing techniques like binning, box plot, various techniques we are using to eliminate the noisy data, inconsistent data, and redundant data. Okay, so data is quality. So programmer, then business analyst is descriptive statistics is using, and as a data scientist is performing various operations in statistics like mean, mode, standard deviation, maximum, minimum, various operations we are using. Then predictive forecasting and probabilities we are using. And finally, we are getting meaningful and knowledgeable data with help of semantic techniques. We are storing the meaningful, interested information. Then it is a combination of visualization and statistical modeling. We are using various techniques like logistic regression, linear regression, nonlinear regression, and mean, mode, standard deviation we are using. And see, visualization techniques in order to show the output through Tableau to R programming, and we are visualizing the graphs, pie chart, bar chart, etc. Then statistical modeling, we are using linear, non-linear, logistic regression. I'm going to execute those statistical methods. Then data technology, data research, data consulting, real world application, scientific methods. So there are three important characteristics we are discussing. Data volume, what is the size of the data, whether we are handling kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, octabytes, yottabytes, zettabytes, brontobyte, geobyte. What is the size of the data we are handling in the real-time environment? My data is a huge volume of data is presented in the data center. Then data variety, what sort of file I am handling in the real-time environment? I am using audio data, video data, text, graphics, animation, etc. Data velocity, whether I am handling real-time data, near-time data, periodic data, legacy data, batch processing the data, YouTube data, static data, what type of data velocity I am handling, what is the speed I am downloading, uploading the files. Then why do I want to study data science? See, if you are having more data, it gives more knowledge. If you have more knowledge, definitely you are getting more money. This is a caption of big data science or data science. Data science is the process of examining large volume of data with variety of types to uncover hidden patterns, unknown correlations, and we are extracting useful information. That is called data science definition. So this is a caption of data science. You are having more data leads to the more knowledge leads to the more money. So more knowledge leads to the better customer engagement in order to prevent frauds and new products, etc. See why data science is now. In order to increase the business, we are using data science techniques. If you see the first step, data, where we are getting data from various sources, cloud, through cloud databases we are getting, through internet databases we are getting, from through big data we are getting the huge volume of data, that is called a datafication. Then we are applying the pre-processing techniques, then we are applying the classification clustering models, and we are extracting features from the huge volume of data, and finally we are getting the new results, insights and interested analytics. And finally we are visualizing those analytics through bar chart, pie chart, line chart, etc. Okay, so as a data scientist you are performing all sort of information. Then why learn data science? See, in 21st century data science having lot of opportunities, but you must have 5 subjects concepts like statistics and artificial intelligence techniques, data mining techniques, machine learning algorithm, deep learning algorithm. Then only you will get data science, and anyone with the programming language called Java, Python or etc. Problem of demand and supply, a lucrative career, you are having a very good future and in this data science career. Data science is changing the world and data science is future. And Facebook alone generates 1,000 terabytes of data daily, whereas many other organizations like Jet Airways, Stock Exchange, huge volume of data they are going to generate per day. And there are 3 types of data we are handling in the real-time environment: structured data, unstructured data, semi-structured data. With the help of relational databases, SQL, MySQL, Teradata, MS Access, we are DB2, we are creating tables and maintaining the databases. And relational databases, relational less databases like Mongo database, Hive, HBase, Cassandra, we are using unstructured data databases. And Cassandra is a data warehousing tool. Recently, Facebook database, they used to have Cassandra data warehousing and database. Recently, recently they have shifted from Cassandra to Hive, because Cassandra not performing joins and triggers properly. That's why they have shifted to Hive data warehousing. Now it is the Facebook database using Hive data warehousing, and HBase is a database tool. Those are the unstructured database tools. So unstructured data is nothing but audio data, video data, text, graphics, animation. There is no proper schema, there is no proper structure. But with the help of relational less databases like Hive, HBase, Mongo database, Cassandra, we are maintaining database and storing a huge volume of data in the data warehouses. We are using those tools. So in order to process the unstructured data, we are using big data technologies like Hadoop, Spark, MATLAB, or Python, etc. Semi-structured data is nothing but 50% structured data and 50% unstructured data is combination. We can call it as a semi-structured data. And who uses data science? See, there are various big giants in the market. They are using data science, like Google. They are using data science, and Facebook, they are using this data science tools. LinkedIn, Amazon, NASA, and Twitter, and Disney Parks, various big giants, they are using this huge volume of data. In order to process, they are using data science tools like Hadoop, Spark, Python, and Hive, HBase, Cassandra, Woozy, Zookeeper, or MATLAB. And why Python is so popular? Because the Python having rich number of packages, library tools are inbuilt in the Python. That's why so popular. And the data science sources, we are getting various sources. Just now I have explained through cloud databases, through IoT databases, and multimedia databases, financial databases, social network databases, and mobile apps data, Internet of Things data from enterprise resource planning system. We are getting huge volume of data. Through bank transactions, we are getting huge volume of data. Data is everywhere, and it can help organizations in any industry in many different ways. And data has become too complex and too dynamic to be able to process the data, storing the data, analyze the data, and manage the data. Okay, and what is the structure of data science? We are using 3 tiers. First tier, data science. There we are supplying structured data, unstructured data to the big data technologies like Hadoop, Spark, Hive, HBase, MATLAB. And we are processing and applying various techniques. And finally, we are generating the graphs like dashboards, queries, pie chart, bar chart, line chart, etc. And these are the various data file formats we are handling the real-time environment: audio data, video data, text, graphics, animation, etc. SQL files and XML files and Teradata files, various files, log files, photos, image. So these files comes under unstructured data. Then data science is a multidisciplinary, interdisciplinary subject because it integrates statistics and artificial intelligence techniques and data engineering techniques, advanced computing like data cloud computing technologies like MS Azure, Salesforce, and Google App Engine, Facebook Cloud, so Gmail Cloud, Gmail Server Cloud, various giants are presented in this data science subject. If you take statistics, we are using various operations like mean, mode, standard deviation, techniques like linear regression, nonlinear regression, and logistic regression. Data science is a multidisciplinary subject which integrates statistics, AI, machine learning, database, and visualization, pattern recognition, neurocomputing, that various computer science subjects are integrated in this data science. If you take data science roadmap, first we are framing the problem, then we are understanding the problem, and we are extracting features, and we are developing a model. From that model, we are presenting the results and deploying the code. And if you see the data science used to, there are 5 steps we are inculcating in order to process the data science applications, like capturing the data with help of data acquisition, data entry, signal reception, data extraction. Then we are processing with help of data mining techniques, clustering techniques, classification techniques, data modeling, and data summarization. Then we are maintaining data warehousing, data cleaning, data staging, data processing. Then we are analyzing the results, exploratory, confirmatory, predictive analytics. We are using regression, text mining, and qualitative analytics. And finally, we are communicating with the data report, data visualization, business intelligence, decision making. These are the 5 steps we are following in data science. These are the data science 5 key elements, like data mining techniques, like classification, clustering, outlier detection, association rule mining, and recommender engine we are using, and data analysis, and finally data science with help of, and these are the predictive analytics we are using. And this is the data science life cycle. First, we are understanding the business, understanding the problem. Then we are collecting the data science. Then we are preparing the data and exploratory data analysis. Then we are developing the model. Then model evaluation and model deployment. Okay. And uh, this is the analytics cycle, like what is our plan, what type of analytics we are generating. We are generating a numeric analytics, or characteristic analytics, or string related analytics, or Facebook analytics. What is our plan? Then what happened after collecting the data, and how you are generating the interested analytics, and why did it happened with help of machine learning, deep learning algorithms. We are extracting the meaningful interested patterns. What will happen next? We are generating interest analytics. What should we do? With that with that results, we are increasing our own business. Then if you see that these 8 steps we are performing in basic data analytics versus reporting, we are generating the reports. Then we are using the tools, processing the tools. We are handling the different types of files. Then we are applying the data mining, classification, clustering techniques, and then characteristics, what type of characteristics of a data or data science, whether the data is qualitative or quantitative, what type of applications we are generating, then what are the skills are required to generate data science analytics, and skills required, and finally big data, we are generating analytics. So data analytics skills, like you need to have a visualization tools. Okay, then data cleansing. Data cleansing is nothing but we are cleaning the a huge volume of data. We are removing noisy data, dirty data, inconsistent data. Suppose, and my name is Krishna, and my age is 25, my salary is minus 10 rupees. My system unable to process minus 10 rupees because it is an inconsistent data. We have entered the valid data 1 to 1 lakh. If you are giving that the data is valid, so that's why we are doing data cleansing. Then we are using MATLAB tool to process the huge volume of data to generate interested analytics. Then R is a visualization tool in order to generate a huge volume of data. Then Python is also popular programming language. So because a rich number of packages are presented in Python, I have used various libraries like sklearn and TensorFlow, Keras, Torch, NumPy, Pandas, various packages I have used for my health data analytics. Then SQL and NoSQL databases I am using, like Hive, HBase, and Cassandra. And machine learning algorithms, you must have knowledge, like supervised learning, unsupervised learning, and reinforcement learning. I'm going to explain what is supervised, what is unsupervised, what is reinforcement learning with examples, and I'm going to execute algorithms. Then linear algebra and calculus, you must have knowledge, strong Microsoft Excel skills, critical thinking, finally communicating with the end users or stakeholders. What are the components of data science? Without a data, there is no database applications. Data is a collection of factual information. Data can be anything. Data can be audio, video, text, graphics, animation, anything. Then big data deals with the V's like volume, velocity, variety, viscosity, veracity, vision, value, etc. I think everybody knows volume. What is the size of the data? And variety, what is the different files of data we are handling? Velocity, data in motion. Veracity, the data in falsification. I am unable to read the number between 0 to 1, sometimes 0 0.5, 0 0.7, 0 0.9. So it is a problem which data I have to take, which value I have to take. That is called a veracity, vision, value, etc. Then machine learning, learning from the observational data. There are 3 types of techniques we are using. Supervised learning. So there is a target class. Based on the target class, we are classifying the data. Like population of the data, Indian population of the data I would like to classify. Based on the gender, I am classifying the data male versus female. That is called label. Gender is a label. Whereas clustering, there is no label. And based on the similarity behavior, similarity measure, we are calculating the similarity measure. Based on the similarity measure, we are grouping the class. That class is called a clustering. So clustering techniques like k-means clustering, it is a unsupervised learning. There is no label. Then reinforcement learning, based on the punishment and reward, we are solving the problem. So learning from the errors, learning from the experience. The best example is chess game. Then statistics and probability, study of numbers and generating the different numeric analytics with the help of statistical operations like maximum value, minimum value, variance, and mean, mode, standard deviation, techniques like linear, non-linear, and logistic regression we are using. Probability distribution, we are using Poisson distribution, binomial distribution we are using. Then you must have programming knowledge like Python or Java, any one programming language, you must have knowledge. Then these are the tasks, the difference between data scientist and a data analyst. Data analyst is performing business administrative skills like marketing analyst and campaigning management, financial analytics like data exploration, analysis, and insights. As a data scientist, including that data analyst part, and is performing advanced algorithms like machine learning algorithms and deep learning algorithms like DNN, CNN, RNN, various frameworks like VZZNet, RESTnet, GoogleNet, and various frameworks is using and generating insights from the huge volume of data. Then he is developing data product engineering applications. This is the process of data science I have explained. Acquiring the data, that means we are preparing the data and reformat the data and cleansing the data. Once data is prepared, then we are giving to the system. System can analyze the data with help of data mining techniques or machine learning or AI and deep learning techniques. Then we are disseminating how effectively we are using the data is called dissemination. Then we are generating the reports, deploying online applications, interested analytics, and finally we are communicating with the end users. And if you see the data science tools, SAS is a very famous tool in data science. If you want to settle as a data scientist, you must have knowledge on statistics. In statistics applications, we are using SAS tool. Statistics application, you can call it as a statistical application scientist or social analytics. And SPSS tool also famous. So, okay, statistical package for social sciences. This is a statistical analysis systems tool, and Apache Spark is famous in big data analytics. Spark is 100 times better than the Hadoop because Spark handles the real-time data, streaming data, whereas Hadoop deals with the legacy data, old database. Every time data loads from the disk, that's why system gets very slow if you are using a huge computing power even though. Whereas a Spark is 100 times better than once first time it will load from the hard disk, next every time it will read from the in-memory computation. That means through RAM it is accessing the information. Then big data machine learning tool, D3, data-driven databases, MATLAB, Excel, ggplot, Tableau, Jupyter, Matplotlib, Natural Language Toolkit, Scikit-learn, TensorFlow, Weka, various tools where libraries are incorporated in the Python and Java. Why Python is so popular? Because of rich number of packages are presented. I have used and I have developed 6 database applications like COVID virus detection, COVID strain virus detection, Ebola virus detection, prostate breast and lung cancer prediction and detection with help of machine learning, deep learning algorithms. I have used various packages like sklearn, TensorFlow, and Keras, Torch, and NumPy, and various scikit-learn and ggplot, D3, Jupyter, various packages I have incorporated for my applications. And these are the, see, if you want to settle as a data scientist, minimum you must have mathematics and statistics, ethical skills, team player skills, lifelong learning skills, communication skills, real world problem project skills, machine learning skills, data visualization. We are using especially R programming and Tableau to generate the visualization graphs, data wrangling and data pre-processing. In order to process the data, we are using pre-processing techniques like binning, box plot techniques. Then coding skills in Java or Python are very popular tools. So like I have explained skills like a data scientist have a data mining techniques like classification, clustering, association, rule mining, and recommend our engine, etc. In big data, you must have knowledge on Hadoop and Spark, R, etc. MATLAB. Research analytics skills, machine learning algorithms like supervised, unsupervised, reinforcement learning, and any one language, Python or R. Finally, data analysis. So what are the data scientist responsibilities? Management, analytics, strategy, collaboration with others, and other the responsibility, and we are using and 70 to 80 and 10 to 50 machine learning algorithms we are using in order predictive modeling especially. Then in text mining, we are using a 30% machine learning algorithms, and visualization, we are using 5% tools. Then my journey to become a data scientist, my dear students, you must have a knowledge on all these subjects. Okay, so understand customers' behavior and define metrics that matter, translate for non-technical audience, and ask good questions. You will get the good answers, make it actionable data. And in statistics, statistical packages like SPSS, SAS, we are using. Advanced mathematics, we are using like distribution, Poisson distribution, binomial distribution, statistical methods like linear regression, nonlinear regression, logistic regression, experimental design, model fitting. We are using scripting languages like JavaScript, Python, Java, and hacking and coding skills, and database tools like SQL, data governance, data preparation. In data engineering, we are using strains, privacy, and legal, get the right data. So if you want to settle as a data scientist, you must have knowledge. So what are the advantages and disadvantages? See, advantages, it's in a demand right now. Abundance of positions are available. Highly paid career in data scientist, highly prestigious jobs in prestigious companies, and versatile career. The disadvantages like it is a blurry term, like the combination of all the subjects you can incorporate, and problems of data, gathering the data and collecting the data from various security departments. Okay, then what are the various applications, especially in image recognition applications like face recognition, biometric application, speech recognition, voice recognition, whether who's this voice, I would like to find out Joe Biden voice. Just I'm capturing the data and finding whether whose recognition with help of deep learning algorithms like CNN, RNN, ANN, VCGNet, ResNet, GoogleNet, various frameworks I'm incorporating encoders so that I'm recognizing the speech recognition applications. Internet search, price comparison websites, in especially gaming applications. We are using reinforcement learning algorithms, gaming especially. Okay, learning from the experience, learning from the mistakes, learning from the errors, and the digital advertisements, recommender systems, delivery logistics, fraud and risk detection applications. So what are the famous algorithms? What is the future of data science and what are the applications? Massive scale growth, geospatial temporal predictive analytics, hyperfast analytics, embedded deep learning, cognitive machine learning, natural language generation, various algorithms we are using, and applications, especially in cyber security, we are using healthcare, IoT, smart human capital, data for societal, various. So finally, I am summarizing data science introduction. All of them have a tech background in order to have a settle as a data scientist, and machine learning and data mining are the common skills. Programming and statistics, database and visualization are the areas they specialized. And where what are the data science use cases? Amazon using, Uber, Bank of America, Airbnb. So improving searches they are using, increasing customer experience. Bank of America, they are using this data science tools, data science concepts, optimizing rides. Even Uber, they are using for optimizing rides, improving e-commerce experience, and a few more use cases like product delivery and online dating, like especially e-commerce websites, Amazon, Flipkart, they are using data science tools and techniques, internet searches, face recognition and image recognition, healthcare analytics, and data science in pharmaceutical, especially in industries, predictive modeling, maintaining oil and gas supply, data science in biotechnology, data science in education. Okay, so far introduction is completed. Now I am going to execute uh, 5 subjects like statistics, techniques. I am going to show you practicals. Please ask me any doubts if you are having. So far I have explained only introduction part, introduction about data science. Sir, please unmute them. Let them ask any queries in their mind. Sir, please unmute them, sir.
Sure, sir. Sure, sir.
Yeah, please, sir, please.
So those who want to speak can please raise their hands using the option available in the ellipsis. So all the participants are able to unmute themselves right now.
Please ask. No hesitation. Please ask me any doubt. If you are having any doubt, please. Hello, my dear friends.
Sir, I had a doubt, sir. So
Yeah, please, sir.
you have expressed about several tools that are to be used with the data science, and you
Yes, sir.
you have also touched about different subjects that are to be used there.
Yes, sir.
Can you suggest the best one for the beginner to start with? I mean, the best tool to start with the learning of the data science.
Yes, sir. Very good question, sir. So my friend asked about as a beginner, what is the subject is required. If you have a basic mathematics, that's enough. You can use Python programming. It is a suitable for every first year student. They are learning Python programming. Even if you are having a basic mathematics is enough to solve numerous applications with help of Python programming. It is a see in Python, you want to have different data types and how to read image and how to use any packages. Very basic level Python programming fundamentals are there. You can learn easily. Arrays, lists, and stacks, queues, various data science, data structure techniques are there. So Python is suitable for data. I mean, for a data scientist, you can choose Python programming as a beginner level. You can settle as a data scientist. Or next, my dear friends, my dear students, my dear faculty members, please interact with me. If you are having any doubts, please.
One doubt, sir.
Yeah, please, sir.
So what are the future risk of data science and artificial intelligence in your opinion?
Yeah, very good. What is, may I know who's this?
Dr. Ali Mirza from Krishna University, sir.
Was a very good question, my dear friend. See,
Thank you, sir.
there are various challenges still. Privacy and preserving security. See, in future, after 10 years, you may not get job because of this automation, especially in artificial intelligence. Still, you are having very good knowledge in these 5 subjects. Definitely, you are having a fair chances to get a job. My opinion, everything, every office, every industry becoming automation. That means it reducing manpower. So this is one of the big problem in future after 10 years. I'm not saying below 10 years. After 10 years. Very good question, my dear friend.
Is it
So,
endangered to humanity?
yeah, definitely. Because see, in organization we are working 100 people. After applying automation tools like robotic process automation, I'm using UiPath in order to develop automation applications to reduce the manpower. I'm using a robot. Robot is performing 10% task at a time. So better I can choose why I am paying money to 10 people. Definitely I can go for a robot or intelligent agent. It can perform very easily without any error. Definitely, sir. My
Did
dear
we
friend,
need
very good question.
did we need any open form discussion to find the risk of this AI and machine science?
Yeah, definitely. After 10 years, you must have an open forums meeting. See, my friend is asking very beautiful question. So in future, that's why every day you need to update, every technology you need to update. Then only you can survive in industry, especially. Now data science is ruling industry right now. We have seen data mining. After that data mining, we have seen cloud computing. After cloud computing, we have seen big data technologies. After big data technologies, now IoT. After IoT, now data science is leading in the market. So
Yes, sir.
this is
There is a technology regarding gene editing called as CRISPR. It is a real
yes.
problem.
Yeah, exactly.
Thank you very much. Thank you, sir.
Yeah. Very good question. My dear friends, my dear participants, please interact with me. Any doubt related to data science fundamentals? Now you can see the practical session. Please ask me any doubts.
Sir, could you please express some research areas in the domain of data science, sir?
Yeah. I opinion. See, I have mentioned that slide also in the last. I'm going to explain what are the research. That research issues, challenges of data science. I'm going to give you. Already, I have given some use cases where we are using data sciences. If you see my slide, you will see these are the image processing, image recognition, speech recognition, price comparison websites, gaming application, digital advertisement, recommender systems, health data analytics, even road accidents, streaming data. I'm collecting traffic data analytics, and you can apply these data science tools. And one more, YouTube data analytics, like streaming data analytics, like BSC, NSC, Bombay Stock Exchange, and a National Stock Exchange, time series data applications. These are the various time weather forecasting and digital supermarkets. Various applications are there. I'm going to share with you. I'm going to show you practicals. Various challenges are there. Yeah.
Okay,
Please,
sir. Some students wants to ask a question, sir. I'm just unmuting them.
Yes, please, sir.
Yes, Nadimit Shivapurma, you can ask your question now. You unmute yourself and speak.
Yeah, please, sir.
Sir, why we need other subjects like cloud computing and Internet of Things in data science, sir?
Very good. Varma, you have asked a fantastic question, because see, cloud computing is a backbone of storing of large amount of data. We require data center. See, how many servers are required in order to store Facebook data? How many servers are required? Huge volume of numbers servers are required. Who will supply these servers? In order to purchase a server, this is too much cost. That's why we require cloud computing, because cloud computing, they are using a huge volume of servers, and collection of integrated servers at one place is called a data center. We are taking license from the Amazon, like they are giving very less cost price. If you want to run your application within 6 months, you are taking license from the Amazon EC2 and S3 cloud service for computing power and storage power. No need to purchase some crores of some lakhs of servers physically. That's why we require cloud computing knowledge, where the data is storing, data center. From the data center, I can get the data for computing power. See, my system unable to run the application because of computing power. If you take a license from the Amazon EC2 and S3, they are giving huge computing power to run the huge volume of data. And that's why I'm using cloud computing. Varma, understood? And one more question, you have introduced the IoT. IoT, Internet of Things, collection of real-time objects in a network is called IoT. In order to get the real-time data, I'm using various sensors in the VIP buildings or airports and railway reservation system, bus stations. I'm capturing the huge volume of data, real-time data, with help of IoT technologies. That's why I require IoT technology knowledge to perform the data scientist role.
Okay,
Varma,
sir.
understood? Very good, Nana. Very good question. Very
Sir,
good question.
Pranit Reddy wants to ask something, sir. So,
Yes, sir. Please.
yes, Pranit Reddy, please.
Hello, my dear
Sir.
friend, please ask me. Yeah.
Good afternoon, sir.
Yeah.
So
Good afternoon.
enough that we cannot control it. Then what is
Sorry?
the how can we
Sorry?
control security, sir? We don't have that much enough cyber security, no, sir. We have enough data, lots of data, but we don't have enough security to protect it, no, sir.
Yes.
I heard that in Microsoft Azure, one lady find a bug. They can hack into our computers who are using Azure, so that the data is being increased, but security is not being increased, no, sir.
Yes, Pranit Reddy, hats off to you, because this is a fantastic question. Still research is ongoing, because security is a major problem for the data. We are collecting data from a huge volume of data from various sources. There are three types of security mechanisms, like data security, network security, and host security. In order to increase the security level, we are using various security algorithms like RSA, DAS, and a few more belief logic, and a few more. We are integrating with encryption, decryption algorithms in order to make very strong security. So still data scientists are pursuing and still ongoing this problem. Still research gap is there in order to increase the security levels of this privacy preserving of the data. Yes, you have rightly pointed out security is a very major problem. Still research is ongoing, and they are incorporating various security mechanisms and security algorithms in order to make a privacy preserving concept in the huge volume of data. Very good, Pranit Reddy, you have asked very good question.
Sir, now Ayesha wants to ask something, sir. So, Ayesha, please unmute and speak, Ayesha. Sheikh Ayesha, please.
Evening, sir.
Ayesha, yeah, good afternoon, Amma.
Sir, you said that one needs a tech background, right? So,
yes.
Some other students who are not from this tech background, if they are going to learn this data science, then what are problems they can face while learning this data science, sir?
Okay, very good question, Sheikh Ayesha. I am appreciating you. Fantastic question. As a non-computer science student also can learn easily data science, but they require a few fundamental knowledge on mathematics. Up to 10th class or intermediate mathematics is enough to settle as a data scientist, they may face problems like analytical skills, real-time problems, how to pre-process the data, and analytical skills. If they have good thinking skills, they can resolve that problems while settling as a data scientist. Non-background students also, if they don't know Java, but they can settle as a data scientist with help of statistical package tools are there. Statistical package for social science and SAS tools are there. And if they want to settle as a programmer or a data scientist in deep manner, they must have knowledge on Python, various frameworks like Keras, TensorFlow, in libraries.
Sir, your voice is breaking, sir. We are not audible. You are not audible, sir. Hello, sir. Srinivasan, sir. Hello, sir. Are you there, sir? Sir, please unmute yourself, sir. Okay, so before sir relogs in, there is a small announcement for the participants. The feedback link will be shared within few minutes in the chat box. So all of you are requested to fill up the feedback form to get your certificate. You are requested to fill the feedback form to get your certificates. It will be shared in a few minutes. Thank you. ఇంకో సిస్టమ్ నుంచి వచ్చారు. ఇంకో సిస్టమ్ నుంచి వచ్చారు.
Sir, my screen is, hello, sir.
Sir, you are audible now, sir.
Yes, sir. Shall we start practical session, sir?
Sure, sir.
Yeah. So 5 subjects we are going to handle in this data science. First one is a statistics. I think everybody knows why we are using statistics. In order to generate interested analytics of population data, wherever a huge numeric data is presented, we are using various statistical techniques. So statistics can be used to derive meaningful insights from data by performing mathematical computations. There are 2 techniques we are using. Okay, so like quantitative technique and qualitative technique. Then there are descriptive methods and inferential methods we are using. Again, in descriptive methods we are using univariate, bivariate, multivariate, and inferential methods we are using central limit theorem, binomial theorem, hypothesis, normal distribution applied to means, t-test, ANOVA, etc. In more advanced probability and statistics we are using central tendency. In central tendency we are calculating mean, mode, and outliers, median, standard deviation, etc. And in measures of spread we are using range, standard deviation, variance, quartiles, and percentiles we are using position of data, percent, and percentile of rank, percentage of rank. Then probability and distribution we are using uniform, normal, Gaussian, position. Then dimensionality reduction we are using a pruning techniques, PCA, principle of component analysis. Sampling techniques we are using SRS, reservoir, undersampling, oversampling. And Bayesian statistics we are using measuring belief or confidence formulas we are using Bayesian theorem. P of A by B is equal to P of B by A into P of A by P of B. And covariance and correlation, how data is related. So then comes to the linear regression. So y is equal to mx plus c. Everybody knows where x is a explanatory variable and y is the dependent variable, and in the slope, whenever you are supplying the values x0, y0, x1, y2, x3, y3, we are generating the graph, linear regression, and machine learning. And this is the algorithm I have implemented in Python programming. Import package, required packages, provide data, and create a regression, check the results, and apply the model. This is the way I am supplying x1, x2, x3 values and parameters like C1, C0, C1, C3. Then I am using, in order to generate C0, C1, I am using formula C0 minus alpha into h of x minus y, and repeat this step. So this is the Python code, linear regression Python code. See now my screen is visible. Please acknowledge me, sir. My screen is visible.
Yes, sir, it is visible.
Notepad, just I'm typing the program, linear regression. See, this is the program. Import NumPy package in order to solve this linear regression problem. Now I am going to execute Python linear regression. Okay, I'm executing this program. So very simple. I'm going to share with you this code to your coordinator. All the programs, all algorithms codes I have incorporated in the PPT PowerPoint presentation. So now I am executing linear regression. Now see, I have taken x-axis. Sir, my screen is visible, sir?
Yes, sir.
So I have taken X value 5, 15, 25, 35, 45, 55. And before reshaping the values, after reshaping the NumPy, with help of NumPy package, I am solving this mean, mode, slope, intercept, and predictor response. And finally, I'm generating the graph like this. Okay. And one more algorithm I'm going to execute, Python. So Python non-linear. Okay. And
Excuse me, sir.
logistic.
Sir, could you please stop the presentation and share it again, sir? Because for some of the participants, it's not visible.
Yeah, it is not visible, sir.
It's visible to most of us, sir, but some of the
Yeah.
people they are unable to use this, sir. So please reshare reshare the screen, sir.
Okay, okay, sir. Now my screen is visible, sir.
Yes, sir. Yes, yes, you can continue, sir.
Okay. So after executing logistic expression, the X values I have taken 0, 1, 2, 3, 4, and I got the values like 0.61. I got intercept value, coefficient value, and like this you can execute logistic expression. See now, this is the code I have written for linear regression, and same values I have generated. And non-linear regression, we are using the y is equal to a0 plus b1 x1 square, and based on the y is equal to mx plus c, multiple forms. So in x-axis I'm generating the values, in the y-axis I'm generating the values. Like see here, I'm x-axis I'm taking minus 5.0, 5.0, 0.1, and I have generated, this is the graph, and this is the logistic regression. Based on the logistic expression, based on the true values like true or false, 1 or 0, we are generating the graph. So the output value is 0 or 1, especially we are using COVID virus detection, whether the image is positive or negative. We are using this logistic regression in order to solve real-time applications. And this is the logistic regression code. And this is the values I have generated right now. Sir, my screen is visible, sir? Krishna Mohan, sir.
Yes, sir, it is visible, sir.
So after executing after executing three algorithms, we are going to see the few more statistical techniques like what are the few more statistical techniques. Linear regression, we are using simple, multiple, and in classification we are using logistic discriminant analysis, linear discriminant analysis, quadratic equation, and subset selection we are using forward, backward, stepwise, best. Tree based methods like decision tree, bagging, boosting, random forest, etc. Support vector mission is used for classification. Unsupervised learning, we are using k-means clustering, principal component analysis, hierarchical clustering. Dimension reduction, we are using PCA, regression, and partial least square method. Shrinkage, we are using a page ridge regression, resampling methods, various methods we are using. Now see data scientist versus data analyst. Background, a data scientist deals with the various data operations. Data analyst role related to data cleaning, transforming, and generating inferences from the data. Scope, involved with several underlying data procedures, and involvement is limited to small data. And the types of data, it handles structured, unstructured data, whereas data analyst deals with the only structured data. And the skills you require: data scientist process knowledge of mathematics, statistics, machine learning algorithms. Whereas in data analyst has problem solving skills and knowledge of basic statistics, and proficient in SAS, Python, or TensorFlow, Hadoop, Spark. Whereas data analyst knows Excel, SQL, or etc. And these are the differences between data analyst and data scientist. Historical data analysis done by the data analyst, future predictions done by the data scientist. Basic programming is required for a data analyst, and advanced programming knowledge is required for a data scientist. Static modeling in data analyst and advanced programming for a data scientist. And less pay and less experience in data analyst, more pay and more experience. Then second subject is artificial intelligence. Artificial intelligence is nothing but intelligence behavior in a machine. The science and engineering to make intelligent machines. The beautiful definition revealed by the John McCarthy in the year 1977. Intelligence, the ability to learn or understand or to deal with the new or trying situations, specifically, especially the ability to reason, the ability to solve novel problems, the ability to act rational and efficiently, the ability to act like humans. So artificial intelligence refers to the simulation of human intelligence in a machine. As if you might have seen the Sophia. Sophia is a humanoid robot. So Sophia took the citizenship in Dubai and Saudi Arabia. So they have developed many expert systems related to human activities. So in order to build the expert system, we are using if-then rules and collection of rules and building an expert system. Then they are checking with that rules whether this intelligent agent is working properly or not. There are few more humanoid robots like Asimo, Sophia, and recently some chatbots came, Alexa. Based on the intelligent systems, we are developing various applications. So what is AI? AI is a popular branch of computer science that concerns with building intelligence behavior in a machine, smart machines capable of performing intelligence tasks with rapid advancements in deep learning and machine learning. The tech industry is transforming traditionally, and where this AI is used. See, predictive analytics we are using, real-time operations we are using, customer services, risk management, customer insights, pricing, promotion, research and development, knowledge creation, fraud detection, human resources, supply chain management, and customer experience. These are the 5 important concepts of AI: machine learning and deep learning and neural networks, collaborative filtering, and predictive intelligence. So the intelligence, how the part is taking in data science. So we are taking data from various sources. We are generating analytics with help of machine learning and deep learning techniques. So this comes under machine learning, deep learning are the sub branches of artificial intelligence. And then we are solving computer vision and NLP, natural language processing application, generative models, and we are using deep learning, data mining techniques, and big data. So what are the features of AI? So deep learning algorithms we are using like DNN, CNN, ANN, deep neural networks, convolutional neural networks, and recurrent neural networks. And the face recognition application, biometric applications we are using. And automate tasks, we are using automated tasks. Okay. And data ingestion, automated tasks, cloud computing, quantum computing, chatbots. And one picture with the data science, like see, we are using data mining, raw data collection, data processing, data cleaning, exploratory data analysis. Then artificial intelligence came here, models and algorithms, neural networks, data production, and intelligent agents. then communicate, visualize reports, and finally make decisions. These are the expert system in AI, history of expert system, characteristics, and why expert systems in order to build the rules and regulations of a robot, where to move, how to move, and what is the task we have to insist, and we have to build the expert system. What are the components and what are the algorithms and advantages and limitations, and what are the pros and cons of AI? Advantages like increased efficiency, reducing human risk, aid in decision making and availability, and the cons, cause of unemployment, high initial investment, dependency on machines, lack of creativity. These are the top 10 most popular AI algorithms: linear regression, logistic regression, and naive Bayes, K nearest neighbor, learning vector machine, support vector machine, bagging and boosting, deeping neural networks. Okay, data scientist versus artificial intelligence. The scope is involves various underlying data operations, whereas in AI, limited to the implementation of only machine learning algorithms. Then structured and unstructured data can handled by the data science, whereas in artificial intelligence, standardized in the form of embedding and vectors. Tools we are using in data science are Python, SAS, SPSS, TensorFlow, Keras, Scikit-learn, and we are using Scikit-learn, Cafe, PyTorch, TensorFlow, Shogun, Mahout in artificial intelligence. Applications: advertising, marketing, internet search engines. Whereas artificial intelligence, manufacturing, automation, robotics, transport, healthcare. Then coming to the data mining, first briefly, I would like to cover all the theory topics. Then I'm going to show you practicals. So data mining is nothing but extracting meaningful interested patterns from the huge volume of data. There are 4 stages: data sources, exploration, data modeling, and model deployments. Next is the mother of invention. This is the well-known proverb given by the Han and Kumber in the textbook Data Mining and Data Warehousing textbook. So for Nesty is the mother of invention. If you want to invent something, so this is the proverb you must remember. So data science versus data mining. In data mining, we are performing extracting data, discovering hidden patterns, developing predictive models. In data science, we are performing qualitative analysis, multidisciplinary analysis, unstructured data, data products. These are the top 10 algorithms in data mining. C 4.5 and k-means, a priori algorithm, AdaBoost, naive Bayes, CART, classification and regression tool algorithm, PageRank algorithm, support vector machine. These are the top 10 softwares like Veka, Vaikato environment, knowledge for analysis. So two faculty members developed at Waikato University. This is a data mining and analysis tool. Rapid Miner, NIME, and Mahout, Rattle, R programming, Orange, natural language toolkit, Scikit-learn, MATLAB, library, support vector machine. These are the top 10 data mining softwares. Data mining algorithms I have already explained. C 4.5 classification, 4.5 version for classifier algorithm. K means clustering. Support vector machine is a classification. A priori is a frequent pattern mining algorithm. Expectation maximization algorithm. PageRank, AdaBoost. These are the few more reinforcement learning algorithms. K nearest neighbor, naive Bayes, classification regression tool. So these are the various data mining concepts we are integrating with the data science, computer science, machine learning, statistical mathematics, business analytics, software development, etc. Then data mining and data science analytics. So what type of data can use in data mining? What type of algorithms we are using in data science? What is the decision finally? If you see the concepts in data mining, we are using data warehouse. See, data mining is nothing but extracting meaningful interested patterns with help of data warehousing, data engineering, data profiling, data translation, data mining, discovery, text mining, machine learning, computer science, rich data visualization, knowledge discovery database. In data science, see, science and scientist, information science, statistics, predictive analytics, advanced analytics, probability models, statistical learning, pattern recognition, uncertainty modeling, artificial intelligence, decision support. In analytics, we are generating health data analytics, business data related analytics, economics related analytics, finance related, and security related, risk related application, biological science related application, various applications. Next, machine learning. Learning from the observational data is called machine learning. So it is a sub branch of artificial intelligence, and we are using three types of learning, machine learning algorithms like supervised learning, unsupervised learning, and reinforcement learning. See, this is the way we are introduction to machine learning. Ordinary system we are taking as input. With AI we are performing, and we are applying machine learning algorithms like classification, clustering, association rule mining. Finally, we are developing a model. That model is predicting results. It improves accuracy. It learns itself. Then these are the three types of machine learning algorithm. Supervised, it is a task driven related algorithm. Supervised learning, based on the target class we are classifying the data. Examples, various classification algorithms support vector machine, linear regression, nonlinear regression, logistic regression, decision tree, neural networks, etc. Unsupervised learning, data driven related applications, and there is no label. Based on the similarity behavior, we are calculating the similarity measure with the help of Euclidean distance, square root of x1 square minus y1 square plus y1 minus y2 whole square, square root of. So this is the Euclidean distance. Not only Euclidean distance, there are few more distances like Manhattan distance, Minkowski distance, etc. Then reinforcement learning, learning from the errors based on the punishment and reward. We are solving the applications. So supervised learning based on label, we are dividing the data. Unsupervised learning based on the similarity behavior, and reinforcement learning, learning from the observation. So here I am taking as a Facebook data, I mean any data, and we are training the model, and we are developing a model. That model is taking the decisions. Okay. So this is the life cycle of machine learning. Data gathering, data preparation, data wrangling means pre-processing the data, data analysis, model training, model testing, deployment. So first we are taking input data, analyzing the data, find patterns, predictions, and store the feedback. Though these are the various examples of machine learning: self-driving cars, and predicting illness, credit worthiness, computer vision, agriculture, ranking in social media, targeted emails, and quality and assurance-based platforms, fashion industry, etc. So this is under reinforcement learning. There is one scenario I am going to explain. Please listen carefully. Okay. So there is an intelligent robot. First, it is observing one side a fire, one side a bucket with full of water. First step, how to develop an intelligent agent based on the observation. It will capture through sensors. It is capturing. Select action using policy. Then if it does wrong step, it will deduct a minus 50 points. Then again it get reward or penalty. We are giving penalty here. Then it will self-healing, self-rectifying, learning from mistakes. Then it observed that there is a bucket of water. I need to pour it on the fire. Then update policy, learning step, and iterate until an optimal policy is found. This is the best solution example for reinforcement learning. These are the types of machine learning algorithms. Supervised learning, we are using classification regression. Unsupervised learning, we are using dimensionality reduction and clustering. And reinforcement learning, we are using gaming, inventory management, robot navigation, etc. And if you take regression, linear, polynomial, decision tree, random forest classification, we are using KNN trees, logistic regression, naive Bayes, SVM. In clustering, we are using support vector dimension, principal component analysis, k-means. In association rule mining, we are using a priori, FP growth. And reinforcement, we are using continuous data, and categorical data, we are using hidden Markov model under reinforcement learning. If you see the machine learning, what are the supervised learnings? We are using regression techniques, classification techniques. Unsupervised learning, we are using clustering techniques and dimensionality reduction with examples. Reinforcement learning, we are using robot navigation, real-time decisions, game AI, and skill acquisition. So then we are using developer tools like Pandas. It is a package in Python, and predictive model markup language and machine learning models, and portable format for analytics. We are using Mongo database in order to handle the unstructured data. Hadoop is a software framework in order to process the big data analytics. And we are using Spark. Spark is 100 times better than Hadoop because it takes in-memory computation in order to solve the streaming data. Streaming data is nothing but flow of data between one end to another end. You are downloading movie from torrent website to your system. So sort of applications we are developing, we are using Spark. And these are the various tools. Machine learning softwares I have explained already. Veka, Apache Spark Machine Learning Library, RapidMiner, H2O AI, Shogun, NIME, and OR YX2, Apache Mahout, PyTorch, TensorFlow, Keras. Applications, image processing, especially we are using applications, medical diagnosis, statistical arbitrage, learning associations, classification, prediction, extraction, regression. Advantages, various advantages, like we are increasing the accuracy and we are decreasing the error rate. Easily identifies trends and patterns, no human intervention needed, continuous improvement, and handling multidimensional and multivariate data, wide applications. Okay, disadvantages like data acquisition is a problem, time and resources, interpretation of results, higher susceptibility. These are the various applications I have explained already. Automatic language translation, especially natural language processing, medical diagnosis, stock market exchange, online fraud detection, virtual personal assistant, email spam filtering. If you see the Gmail account, we are see if that mail is not important, we are moving to the spam. It is a classification, a real-time example. Self-driving cars, it is a trend now. Google started already, now it is in the market. And product recommendations like Amazon and Flipkart. Recommender engine algorithm is working in that principle. Traffic prediction, speech recognition, image recognition. And the last subject is deep learning, learning from the actionable data with the deep manner, learning from the observational data from the deep manner. It is a sub branch of machine learning. Machine learning is a sub branch of artificial intelligence. So here we are using two types, supervised learning and semi-supervised learning. So this is a word cloud of deep learning. And here we are using various algorithms like DNN, CNN, and RNN. Suppose for classification, I'm using a deep learning. Whether I'm while running cars in the road, I would like to find out which is a bus, which is a car, which is a jeep, which is a lorry. So in that application, I'm using deep learning concept. I'm giving input to the system as a car. Based on the features, there is no human intervention. Itself, it will, based on the features, it can classify the data. Based on the label, we are classifying whether it is car or not. So machine learning, deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. Artificial intelligence is nothing but intelligent behavior in a machine. That is called artificial intelligence. Learning from the observational data is called machine learning. Learning from the actionable data with the deep manner is called deep learning. Deep learning uses neural networks to simulate human-like decision making. And these are the differences between artificial intelligence, machine learning, and deep learning. In the year 1950s, artificial intelligence came. John McCarthy given a beautiful definition and a concept of artificial intelligence. Then 1980s and 90s, machine learning came. It is ability to learn without being explicitly programmed, whereas deep learning in the year 2010 until date, learning based on the deep neural networks. There is no restriction how many hidden layers, how many input layers. You can use n number of hidden and input layers. Okay. So who invented deep learning? In the year 1960s, it is came into the market. So Alexei Ivanenko created. He is from Russia, mathematician. He introduced the deep learning concept. He developed a functional neural networks, which is considered to the first serious deep learning breakthrough. He published a paper on functional neural networks. Okay, using multi-layered networks for machine learning, that is called deep learning, training machines to get better at a task without explicitly programming. We are using machine learning, enabling machines to think like a humans. Why deep learning? It can increase the accuracy, it can reduce the error rate. So automation purpose of the data. Okay, and we are using how do data scientist techniques scale with the amount of data. Then okay, so this example comes under reinforcement learning and deep learning model life cycle. We are taking data and labels and reference models and create update model, then train and testing model, evaluate model, and finally it gives the results. So these are the machine learning programming languages, Python, or machine learning tools like TensorFlow and scikit-learn, Veka. These are the libraries we can incorporate into your application. Keras, PyTorch, deep learning tools, analytical tools like Spark and Hadoop. Especially we are using big data analytics tools, visualization tools like Matplotlib. Okay, Jupyter we are using. And I have explained, see the difference between machine learning and deep learning. In both cases, we are using same input as a car, but human intervention is present in the first machine learning. There is no human intervention in deep learning. And finally, we are applying algorithms in both cases. Finally, we are getting car or not. Then deep learning, machine learning differences, data needs a big data sets and less data sets, machine learning. Hardware requirements requires mission with GPU, graphical processing units work with low-end missions. Engineering peculiarities needs to understand the basic functionality of the data and understand the features and how they represents the data. Training data time very long and training data in machine learning short. Processing time a few hours or week, a few seconds. Number of algorithms few. Machine learning many algorithms are there. Data interpretation difficult and some machine learning algorithms are easy to interpret. So this is the way we are using data learning process. So n number of input layers we are taking, n number of hidden layers we are using, because in order to increase the performance and accuracy of the system with a deep manner, that's why we are getting very good accuracy. And these are the three important techniques we are using: deep neural network, convolutional neural network, recurrent neural network. Okay, and we are using deep learning models, supervised models, unsupervised models. So we are convolutional neural network, classic neural networks, recurrent neural networks, and unsupervised self-organizing maps, Boltzmann machines, auto encoders. And these are the DNN related. What are the DNN? Deep neural network performs classification, computer recognition, vision, and prediction and time series prediction. CNN, it is all for three application: computer recognition, computer vision, especially CNN for uh, image classification, whereas RNN for long short-term memory for video and audio applications we are using integration. So these are the deep learning methods: AlexNet, CNN based methods, RBM based methods, autoencoders, and sparse coding based methods. So again, a CNN based method: AlexNet, Clarify, SPP, VGG, GoogleNet. And RBM, we are using deep belief networks, deep Boltzmann machines, deep energy models. In autoencoders, we are using sparse autoencoder, denoising autoencoder, and contractive autoencoder. And sparse coding based methods, we are using sparse coding, Laplacian sparse coding, local coordinate coding, super vector coding. So these are the top 10 open source deep learning tools. TensorFlow, it is a library for especially speech recognition and translation model. We are using TensorFlow. Then the Microsoft Cognitive Toolkit, especially for image, speech, and text-based data, we are using CNN methods. And Cafe, one of the deep learning tools built for scaling and for track of speed and modularity and expression. Chainer method, it is one more open source deep learning method, Python based deep learning method, automatic differentiate APIs based on the define by run approach. Keras, it is also one of the framework or library we can incorporate to solve deep learning applications, both CNN and RNN application. Keras is a popular choice for many. So deep learning 4J, it is also one of the library JVM based, especially for Java based tools. These are the tools of deep learning algorithms, TensorFlow, Python, MaxNet, C++, Java, various tools we are using. Okay, applications, n number of, wherever data complexity is there, we are applying data learning applications, especially predictive applications, chatbot applications, self-driving applications, read lip movements, and colorizing the images, medical care, photo description, advertising. These are the 10 fascinating applications of deep learning. Self-driving cars, detection of growth delays in children, automatic handwriting generation, demographic prediction, pixel restoration, sound addition to silent films, and colorization of black and white applications, new aggregation, deep learning, and automated machine learning algorithms. These are the various applications we are using. I have already explained these applications, and 10 applications, especially self-driving cars and e-commerce, banking, manufacturing, healthcare, transport, finance, and what type of, especially, see, data science, real life use cases, learning to speak, what sells most ice creams, recognizing defects. In order to find out, these are the interested analytics, we are using deep learning algorithms. These are the tools we are using, and a deep learning pipeline, data streaming, users, framework cluster, models, and finally we are generating the interested analytics. So if you want to settle as a data scientist, you must have IDE knowledge on PyCharm, Jupyter, and Spider, RStudio, Java-based IDEs, Eclipse, etc. Programming languages like Python or Java, data visualization, Tableau, Power BI, Matplotlib, ggplot, especially in computer vision, we are using ggplot, Seaborn, web scrolling, we are using Beautiful Soap, and Scrapy, URL lib, deploy, we are using for deployment purpose, we are using Amazon Web Services, Azure. These are the popular clouds in the market. Mathematics, we are using statistics, linear algebra, differential calculus, data analysis, feature engineering, data wrangling, data pre-processing, and etc. Machine learning, classification, regression, reinforcement learning, deep learning, clustering, dimensionality reduction. These are the various tools we are using. Okay, development tools are there, languages are there, data platforms, deep learning virtual machines, AI and machine learning tools, data ingestion tools, etc. So these are the various tools I have explained already. This one. These are the challenges. Krishna Mohan sir asked what are the research issues in data science. Sentiment analysis they can use. Opinion mining. How Joe Biden won elections in America with the help of data analytics. Like 50 states he has given SMS, voting system, and some tools. He got the data from various sources. He analyzed only 5 states are lagging, his opinion. Then he increased boons and uh, um, uh, current free, so amenities are free for public. Definitely people are voting for Joe Biden. Opinion mining applications with help of deep learning algorithms. Okay, these are the research challenges. So driving the success of data science solutions, skills, roles, responsibilities I have mentioned here. So IT skills like data logistics, high performance computing, etc. Data science we are using which analytics to choose. According to Gartner survey, which tool is famous? Depends on the requirement, depends on the scenario we are solving. So wherever data complexity is there, we are using data science applications. According to the Gartner survey, these are the challenges of data science. Dirty data wherever presented. We are using data science tools. Lack of data science talent. Gartner is a famous scientist. He is going to reveal every month which tool is very famous in especially software, especially in hardware, technology wise, he is going to reveal. So which is the better to start AI, ML or DL? This is a common question. So depends on your problem situation. Any technique which enables computer to mimic human behavior, you can choose artificial intelligence. Wherever complex data is presented, so subset of AI techniques which use a statistical method to enable machines to improve the with experiences, then you go for machine learning. Subset of machine learning which makes the computation of multi-layer neural networks go for feasible, go for deep learning. So these are the real-time applications. I have executed COVID because of time. I am showing my results. Coronavirus detection. So coronavirus, COVID-19 stands for, CO stands for corona, Y stands for virus, virus stands for vital information resource under siege, D stands for disease. In the year 2019 it came. These are the symptoms: fever, cough, chills, headache, diarrhea, etc. We are extracting the features from the image or voice or video data. So I have taken 980 images. I have extracted the black spots and wherever the marks are presented in the X-ray images, I have collected from the real-time hospitals data. Then I have applied 4 steps like convolutional operation, ReLU layer, pooling. Okay, so then flattening the image, full connection I am using. So convolution operation by with help of rectified linear unit I am using, pooling, flattening, full connection, and these are the steps we are using in. So I have taken 3 types of images: COVID-19, pneumonia, normal image. Then I am applying a CNN or RNN integrated, and I'm dividing into pixels 10 by 10 into 2048. Then I'm building the model and extracting the features, then applying the convolution function conv 2D in CNN, and I'm using dropout in order to increase the performance of the image. So we have used, this is the model, input layer, hidden layer, and output layer. Finally we are getting the results. These are the training data set we have collected, and I have applied CNN algorithm. This is the code I have used. Okay, so training augmentation configuration, testing augmentation, and generates batches of augmented image data, generation of valid data, evaluating model performance on testing, and this is the testing data, and chest ray, X-ray, COVID-19 virus. I got the see, this is severity levels of the chest images, and these are the number of approaches I have run it in the Python. I'm going to share with you this one. Okay, so these are my screens. I have executed data loss versus accuracy, execution time. See, my system completely used the CPU, so busy, and COVID-19 data size versus accuracy. And the same way I have executed COVID strain, same manner. I have collected features and new strain like tongue, on the tongue, so much red pimples. How do we detect those features? Training data set and testing data set. This is the recurrent neural network code I have used and I have
Sir,
executed.
excuse me, sir. The
Yeah.
screen is not visible, sir.
Screen is not visible. Once again, I am sharing, sir. Now check, sir, my screen is visible or not?
It's loading. Yes, sir.
Yes, sir.
Now it's visible, sir. Right, sir. Please continue, sir.
My screen is visible, sir?
Yes, it's visible now, sir. Please continue, sir.
Yes, sir. So this is the RNN code I have used and severity levels I have extracted. And prostate cancer also we have collected the features: cough, coughing of blood, persistent breathlessness. This is the training data set. This is the testing data set and severity levels of the prostate cancer. And breast cancer I have collected various chest X-ray images, and these are the features. So X-ray of breast cancer severity levels I have find out, and lung cancer detection. These are the various features I have collected and extracted the features and severity levels of the lung cancer. Ebola virus, same way, we have collected various features, and these are the training data set I have collected and extracted. This is the COVID data set using RNN. This is the training parameters, testing parameters, graph input, define weights, and LSTM, long short-term cell output. And these are the severity levels of Ebola. And I'm concluding, because of time, I'm concluding 960 images I have taken successfully. And we have found 148, 149 COVID data images are positive, 234 pneumonia positive, 250 for normal and negative. And we got very good accuracy, 89 and 91. And these are the research challenges I have already explained. So these are the few international events I have conducted recently at Thailand and Malaysia, and conferences I have attended. This is a keynote speaker and one of the resource person, and this is also one of the resource person and jury member, and this is one more keynote speaker. This is doctorate from JNTU Anantapur and Bharat Vidya Ratan Award from Delhi in the year 2018, and this is the best ITAP information technology in Andhra Pradesh, best IT teacher award from the AP government, and best local chapter award from IIT Madras, and the international seminar speaker, and Big Data Sangam University and ABS College and Jaya Engineering College, Maharshi Markandeya Engineering College delivered webinar, and this is in Liberia, one of the data science topic in Bluecrest University. This is at Saudi Arabia in Oman, big data analytics using Spark and data science application at Bluecrest. This is at Russia. Recently, I have delivered topic on COVID-19 strain virus detection with practical session, and this is one more data science applications using Python, and this is at Bharatiyar University, Tamil Nadu, and this is Lord's Institute of Engineering Technology, Hyderabad, and this is data science using R programming. This is at Reva University, Bangalore, international panel member, and this is Karpaga Vinayaka College of Engineering. This is Vijnana Bharati Engineering College at Hyderabad, and this is Research Conclave, acted as a resource person, and this is your university, Krishna University, Machilipatnam. Thank you, sir, Krishna Mohan sir, for giving me this opportunity. Any queries, my dear participants, please interact with me. Please unmute them, sir. Sir, please. I'm going to share with you this PPT. Please give it to the participants so that they can execute and interact with me, sir. Hello, sir. Hello, sir. Yeah, please.
Sir, you're audible, sir.
Yes, sir.
Yes,
please,
sir.
sir.
We are waiting for the queries from the participants, sir. So
Yes.
before that, so we are very proud to have a Bharat Ratna Awardee as our speaker today, sir. We are very much thankful to you for spending your more valuable time with us, and you have spoon-fed us the concepts of the data science. You have started from the very scratch of the data science, sir. You are focused mainly on the what is data science, why to learn data science, and how to learn data science. What are the techniques that are involved in the area of the data science? And you have also thrown some light on the research areas also, sir. So we are very happy. And what gives us good pleasure is that you already given the hands-on experience with Python, sir.
Yes,
So anybody, anyone from the participants?
please interact with me. My dear participants, my dear friends, please interact with me. Any doubts? Sir, please share my email ID and phone number to participants, sir. I am sharing my PPT to you, sir.
Sure, sir. We will do that.
Yes, sir. Thank you, sir. Any queries from my dear students? Varma, where is Varma? I'm expecting one more query from Varma, sir. He's very intelligent student. Praneeth Reddy. Okay.
Yes, sir. They are our MCA students, sir. They are
Okay,
very much curious about their careers.
Thank you, sir.
And they have got the good chance to interact with you, sir.
Yes, sir.
Thank you for your patience presentation. Now I request Dr. Vijay Kumari Garu, Head Department of Computer Science, to present the formal vote of thanks.
Okay, sir. Thank you, sir.
Sir, am I audible, Krishna, sir?
Yes, yes, madam, you are audible.
Yes, sir.
Yes, madam. Yes.
Yeah, thank you. I'm Dr. Vijay Kumari. I'm here to propose formal vote of thanks. First and foremost, I would like to thank our Honorable Vice Chancellor, Professor K.B. Chandrasekhar Garu, for being chief patron for this one-day national webinar, for giving permission and for coming over here and delivering the chief guest speech. I would like to thank patrons of the program, Professor Y.K. Sundar Krishna Garu, Registrar of Krishna University and Professor in Department of Computer Science, Professor D. Surichandra Rao Garu, Principal, Krishna University College of Arts and Science. I thank the patrons, both of them. Sir, thank you very much for your presence in this program and also for the beautiful message that you have delivered to us. I like to thank the speakers of the program, Dr. Saroj Kumar Biswas Garu from NIT Silchar for delivering a beautiful message, lecture, and bringing insights to the participants regarding data science applications. Thank you, sir. Thank you very much. I would like to thank Speaker Dr. Asadi Srinivasulu Garu, Blue Crest University, Liberia. Sir, you have given a thorough insight regarding data science applications, machine learning applications, and hands-on programming sessions. Sir, you are well versed with the content, and you gave us lot of knowledge. You filled us with great insights, sir. Thank you very much. Thank you for the elaborated session and for your patience also, for answering the queries from the participants. Thank you, sir. Thank you very much. I would like to thank the webinar director, Dr. R. Kiran Kumar Garu, for giving me this opportunity, and also the organizing committee, Dr. Mohan Garu, Mr. PLN Prakash Kumar Garu, and Dr. Muhammad Ali Mirza Garu, for your excellent support for the program. And last but not the least, I would like to thank all the participants of the program for being very active and interactive in this session, and also for being patient for the long hours. Thank you. Thank you, one and all.
Thank you, ma'am. Now, small announcement for participants. You all will receive your certificates soon, as there is a limit on the certificate generation. Everybody keep on filling the feedback link, and soon you will be able to get your certificates by your email. Thank you, everyone. Now the meeting is dispersed. Thank you.
Yes.